Hey guys, welcome back to another episode of Simuleos. I just realized my microphone is in the inappropriate place, so let me move it really quickly. Sorry about that. Just something like this should be okay, but I know that probably made some noises and I apologize for that one. Okay, so guys, today, what are we doing? Well, we are visualizing the epidemic algorithm that we kind of sort of completed the other day. So, what do we have to do? Well, in my book, we've got about 5 different visualizations we have to make, which means today might be a little bit longer than I anticipated, but hey, who knows? Maybe it's not going to be as long. I have no idea. I don't know how long this is going to take, but in essence, we have everything else. We have everything else that we need already set in the code. We just have to actually do the individual visualizations, and that's about it. Slayer Darth, bad news. Looks like I can't root my Android phone. Oh, I'm terribly sorry about that. Does that mean you bricked it? I'm not sure. I don't know anything at all about phones. Volume up button doesn't work to unlock bootloader. I'm sorry, man. I have no idea how to help. Again, I don't even have a phone myself, so I mean, if the volume down buttons works, that's probably okay, right? So let me go ahead and open up Zernal and let's talk about the different visualizations we're going to need. So we need at least 3, which are going to be 3 different simulations, but we also need 1 or 2 visualizations of what these networks are. Blue. I see. Okay, so here's what we got. We need 2 different visualizations to start. 1, 2. 1 is going to be a pull network. 2 is going to be a push network. Then we need 3, 4, and 5. These visualizations are visualizations of, let me see, how do I put this? Visualizations of actual simulations. So we need 1 with a small number of people. And in this one, we need a small number of people who are not attracted to each other. They are just staying in place, but so not moving. Okay, then we need a small number, but moving, where these guys are going to be attracted to each other based off of their, based off of their affinity. Oh my gosh, come on, screw it, affinity. Why am I not able to spell? Affinity. There we go. And then finally, let me see. The last one's going to be a large number of people, but not moving. Yeah, so I'd heard about HackerRank before. They do a type of coding that I'm not so familiar with, so it's not something that, let me see, hackerrank.com. It's definitely something that I've been told about before. So when people say, hey, I need to learn to code, for some reason they always go to HackerRank. Let me see. For developers, oh, never mind. Oh wait, no, this is okay. Yeah. Yep. Interactive programming challenges, tutorials covering algorithms, C++, artificial intelligence. Yes, of course. So yeah, so I've definitely heard of it before. It seems like it's kind of not up my alley. And I just realized I showed you all my Twitter messages. That's okay, I guess. I mean, who cares? It's Twitter, and I don't think there's anything on there that matters. And again, guys, if your screen is flickering, please feel free to set the screen on source. That will solve the flickering issue. So I guess since these are the simulations we're going to need, I say we just go ahead and get started. I don't see any reason to delay this any longer. Let's do it. So I'm going to CD into projects, Simuleos, and of course viral video over here. Now CD into projects, Simuleos, and viral video. Okay, now I was going to try to see if we can somehow fix that flickering issue, but I don't know. I tried different quality options all week, and I don't know, it didn't seem to work. So let me see what happens. Who uses Twitter when all the cool kids use Thunderbird? I also use Thunderbird for my email client, but I think Thunderbird is a little bit different than Twitter in terms of what they're supposed to be doing. So, you know. I did at some point, actually let me see this, Y-O-U-R-T, Twitter, oh gosh, misspelled Twitter, 1 second, Y-O-U-R-T, Twitter, okay, there, I wanted to find a terminal, console client for Twitter, and Identica, yeah, so I wanted, sorry about that, to use some sort of, something like this, a Twitter client for my my terminal. In fact, I've been thinking more and more about doing this because, quite frankly, there isn't a reason for me to go onto Twitter itself when I could just tweet off my terminal, which would be a little bit more useful for me. But, you know, we'll see how that goes. Okay, let me go ahead and clear here. Control L. And let me open up viralvideo.cpp. .cpp. Okay, now I'm also going to open up .h. Okay, so I have a function that we just kind of created at the end here, which was draw viewers. Yeah, it was like an add-on for Pac-Man. Yes. So you have Pac-Man. Yeah, it's the exactly that, Tasty Lavero. It's basically you have the Arch user repository, and Yaourt just allows you to very quickly search for things. It's not particularly well received anymore in the Arch community, but that's okay. You should use Windows to learn things like that. Wait, how would Windows? Wait, what? 1 second. Windows shell is so much better. I don't know. I'm hit and miss with the Windows shell in terms of whether I should learn it or not. For the most part, I don't see a reason to, because now Windows 10 or whatever and above have Unix terminal compatibilities. So we'll see. I just don't see a reason really to learn anything other than Unix, especially because all of computational physics is done on a Unix terminal. Okay, so we're gonna need a couple different functions. So we're gonna need a function to visualize, let me see, a pull circuit network. Okay, then we're gonna call this, how about void? Let me see. Oh yeah, there's something you can do in terms of editing Pac-Man's configuration file, so that at the end of the installation process for an application, here you are, it shows Pac-Man video game character. Yes, you can actually. What happens is, it's kind of silly how it looks. It doesn't really look that great. I have it on my laptop, but I don't have it here. But basically for the loading, like if you're loading a file, or you're installing a file or something like that, there will be a bar, like with 2 brackets over here, and then on the inside they'll put a whole bunch of pound symbols, right? But if you download this additional application or whatever, basically you have a Pac-Man that's kind of walking along. But why would it all be done on Unix? Surely because of Windows, it would be much more performant and reliable. I don't know if you're trolling or not, CVC, but the reason we can't... Okay, so all supercomputers use... Well, okay, not all, but like 90% or above of all supercomputers use Linux, or at least some sort of Unix. You know, for the most part, they're using Scientific Linux, or they're using CentOS, or they're using something like that, you know? The fact of the matter is, the terminal applications for Unix are way more developed than the terminal applications for Windows. And this is for a number of reasons, right? Because in the end, you have, basically, you have, you know, people still using the terminal regularly in Unix, so they still continually develop terminal tools. And because supercomputers are computers that you're going to have to SSH in, this is a good reason to have a very good terminal client. On top of that, Windows licensing and such like that makes it rather difficult to use for supercomputers and stuff like that, because you can't really extend it to the use cases you want without going through a proprietary vendor. Meanwhile, with the supercomputers that I'm typically using, you just SSH on. You have a super parallel system, and you program for the super parallel system, and then you go from there, you know? So I don't know, I feel like I think there are a lot of good reasons to use Unix, especially for science. Now, in terms of market and stuff like that, I get that everyone likes the market economy, and I get that everyone wants to develop software that you can get paid to develop. So I understand that open source is not like the end-all be-all, it's not like the #1 thing that people use. But for everything that I use, literally everything that I use regularly, Linux works perfectly. There's not a single application that I would like to use that is not that is not on Linux. But this is just my personal viewpoint, right? So other people have different things. Tasty Lavero, I heard science is a lie. That is exactly what my grandmother says, and it's super awkward when I go home. There's a lot of great open source new projects for Linux also, like Octave and R. Yes, so these are good. These are good. But there's also a whole bunch of other ones. GIMP's, yeah, GIMP's okay. I use GIMP all the time. It works fine for everything that I need. But maybe I would need Photoshop for something in the future. Not sure. In that case, there are currently a couple of good software packages coming up. In fact, oh, what was it? There was this one 2D drawing system that had just come out, and it said that, or not just come out, it came out a while ago, but they said that at some point they may consider doing scripting, and if they do scripting, I will strongly consider using that in the future. Can you use syntax highlighting so I can see things better? Unfortunately not, Crib, because if you can see things better with syntax highlighting, I see things worse, and it kind of drives me nuts. Sorry about that. 3D MatCAD is rather limited on Linux. Yeah, so that's true. Yeah, that's true. Why use Photoshop? Why not draw by hand like a real artist? In the truth, Inkscape's not so bad. Yeah, Inkscape is also open source, and it's used a lot for scientific things. I'm now kind of going on this huge rant about things that I don't need to talk about. But yeah, the one thing that I need for my particular use case is I need something scriptable, right? So this is why I'm using Blender for the 3D stuff, and this is why I use Cairo for the 2D stuff. But ultimately, if I could find a good solution for 2D scripting and stuff like that, oh, I'd take that in a heartbeat. You know, if someone could create some scriptable 2D program that allows me to draw everything that I want to draw, and gives me the flexibility I need to use any type of programming language or anything like that, yeah, that'd be great. Sorry, yeah, I've been messing with Inkscape lately, and it's been a dog for me. Wait, what do you mean dog? Is that good or bad? Sorry for distracting you. No, you're perfectly fine, guys. I mean, again, as I mentioned, today's probably going to be a bit of a longer day, so we'll see how far this goes. I mean, it could be that after the 2 hours that I typically stream, it gets super unpopular and no one wants to watch anymore, or it could be the opposite. I have absolutely no idea how this is going to go. Anyway, we got a couple functions to write. So we have to visualize the full network. So we're going to say visualize pull. Now, what do we need for this one? Nothing. I think we can read everything in, and I think that's true for all the other ones. But let's see what happens. Maybe I do need to add something in, and I just forgot what we need to add in. So we're going to do function to visualize a push network. Okay, so we're going to do void visualize push. Okay, now what's next? We have function. Let's see, so this is going to be a function. Oh, that's another thing. So, I love the idea of open source. Don't get me wrong. However, I will totally admit that if I were to get a new computer now, knowing everything that I knew, but not knowing Linux, just knowing everything I know about the Unix terminal and stuff, I would choose a Mac. You know, Macs are good systems that allow you to still use Photoshop, to still use Microsoft Office and everything, and still have a Unix terminal. Like, I'm not gonna lie, Macs are incredibly useful because they have that terminal, and because they have that terminal access, it is a good device to use, and a lot of people use them for physics nowadays because you can SSH onto your supercomputer and you have everything set for you. However, I'm too used to Linux at this point. I'm too kind of entrenched in my ways. I feel kind of like I don't know. I feel like one of those old geezers who tells people to get off their lawn. I'm not bad with Photoshop, just not an expert. Yeah, that's true. The thing is, though, a lot of my friends claim that no matter what you do, the price difference between Mac and Windows will never be worth it. That's what they say, because Macs are always more expensive. So, I don't know. It kind of depends. So, let me see. What do we have here? Function 2. Visualize a small network of viewers. Okay, so we're going to say void visualize small network. This will be here. And now we need other function. Oh my gosh, I can't spell it all. Function to visualize. Oh, this is going to be a long day, isn't it? A small moving network viewers. So this is gonna be void visualize. 1 second. Moving network. Okay, and what I need to do here, let me see. I like my arch due to quartz. Yeah, I actually think AI much better and nicer than Inkscape, especially on a Mac. Maybe. You are an old geezer. Look at your 1950s styles haircut. I'm sorry, okay? I know I need a haircut, but the truth is, this is what happens every time I go to the hairdresser. I go there and I'm like, oh gosh, I can't speak to this person in Japanese. And so I just give them a picture of what I used to look like, and I'm like, I'm done. This is what I want to look like. Just make my hair like this. It's okay. I like my arch with in my ThinkPad with i3WM. Yeah, so that's true too. The sheer flexibility of Linux, being able to install whatever network or whatever 1 second, whatever desktop environment or Windows manager you want, makes it quite nice. Let's use Photoshop and InDesign at work. I've tinkered with Illustrator somewhat, but not much. Have you ever looked at CAD Quarry for 3D stuffs? OpenSCAD. Let me see. Thanks, ADF. So let me see. No, I actually have not. I have not heard about it until now. So what I'm going to do is I'm going to open up a tab, look up CAD Quarry. Query, I guess. And then I'm going to leave it here. Let me see. Images, actually, real quick. This doesn't look so bad, actually. That looks quite nice. Is it scriptable? If it's scriptable, hey, this might be an interesting thing to look into. Okay, and finally we have to do a function. Function 2. Oh, come on, I can spell function. To visualize large network size of canvas. Okay, so we're going to void visualize large network. Okay, so some of these are going to be easier and some of these are going to be harder to do. We're going to have to create a few, we're going to have to create, wait, oh, I don't know how the order came about because I thought I was doing it in a different order, but that's perfectly okay. So, we're going to have to create a couple of accessory functions for the moving network. If I can spell moving network. Let me just make sure I spelled all these right. Visualize, I did not, so I need an AA there. Oops, sorry about that. Visualize small network, visualize large network, visualize moving network. Okay, this all seems good to me. So we're gonna have to have a few different functions being created here, and I've just realized I'm probably gonna need something like an int viewer num for all of these guys. So let me go ahead and add this guy in here, there, 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 and there, and that should be okay, I think. So let me see. To be honest, I'm not creative enough for Photoshop and InDesign, but I quite often make icons in Illustrator, which doesn't nearly require as much creativeness. By the way, I'm considering investing in a Raspberry Pi and installing Linux on it so I can connect it to the Sony TV monitor in our living room so I can use it for browser access. Yes, so Raspberry Pis are pretty cheap. Let me see. So we used to. So during Open Campus, every single year here at OIST, we run this booth called Programming with Neko-chan, where we invite kids in and we teach them the Scratch programming language, which is on scratch.mit.edu. 1 second. Scratch.mit.edu. And when we teach them this, what we do is we basically have them learn the language, right? But we used to use Raspberry Pis for this. So we had a group of, let's see, maybe 5 computers, all Raspberry Pi, super duper nice. It is super duper nice. And I would strongly recommend you trying it out if you want to. I think they're pretty cheap. They're like $25 or something like that, which is pretty good. Okay, so what I'm going to do then, let's see, we also need small and moving network. Yes, so I think this might be all we need. So let's go ahead and grab these guys. And once we create one, the rest of them are going to be easier to create from there. So let me go here, and let's just do something very quickly, just to make sure this all works. So I'm going to go here, open it up, close it down there, remove that line. Remove that line. Remove this down here. That, and that. Now let's go ahead and open up all these guys. Here, and there. Down here at the end. Oh, and there we go. And I should be able to do dot. Yep. Dot. There we go. Dot. I missed a void on this one. So let's go down here and fix that. Okay, so now what I'm going to do is write and quit and make it. Okay, seems to make just fine, I think. There we go, makes just fine. And let me go ahead and do a write and quit, just to make sure it still makes over there. But it should be good. Okay, so now we have all the functions as far as we are. Depends on what you want to use your monitor for. Browser access. Our smart TV doesn't provide browser access. YouTube is the closest it gets. I was considering that a PS3 and installing Linux on that. Can you still do that? I thought there was like some sort of court case or something about that, wasn't there? I feel like, I'm not sure. But I think they definitely removed. Oh, okay, yeah. Just on the cheapest one with HDMI and USB port and wireless. And if it's close to a router, just get one with an RJ45. Was on later gen? I'm not sure. So let's go down here and let's see what we have. We have provide videos. Okay. So it looks to me like we have everything ready. Let me go ahead and go into VI visualize. And then what do I want? I want Cairo. 1 second, and then Cairo viz.h. How many frames do I have? I only have 5 frames, which is okay. I just want to check to see if we can appropriately visualize all of our folks. So what do we have here? We have G down here, and we have draw viewers. Okay, what did I make last time? I don't remember. I made a couple of different functions, I thought. Output viewers. Oh, we gave them all viewer positions. That's what we did. And then after giving them all viewer positions, good. So now that they all have viewer positions, I guess I just want to see what happens if I run this draw viewers command. Why not? Okay, so let's go up here and let me just run a very quick draw viewers command and let's see what happens. So we're going to do draw viewers and we're going to do enum and we're going to do viewers. Let's go over here, write and quit, make. Okay, I don't see why this would break, but if it does, oh well. And we're going to run a.out. Okay, let's see what happens. It is running. Don't know what it's doing, but it says it's running. As far as I know, people at Kotaku install Linux on PS3. But that requires master hackery skills. I'm guessing in PS4 aren't cheap. Okay, so let me do a quick ls of temp. Let me see. Okay, so it didn't seem to make the image, and I'm trying to figure out why real quick. Probably because at the end of main, I didn't tell it to make or draw the frames. So let me go down here, and let's do anim.draw frames. Okay. Let's go here, and let's run it. Let's make it again. Now let's. Oh, you know what? It might have also done it because I ran the wrong. I ran the wrong. Yeah, there we go. So there's our images. Yeah, I do not use Emacs. I only use VI. I don't even use Vim. There's actually a little blurb under my channel about that, how I use VI instead of Vim. But we'll see how this goes. Okay, so now let me see. I'm going to run Mirage temp image 0000.png. Okay, so here are our people. Okay, well that's not quite what I was hoping for. Note that... Where are they? There they are. Yeah, that's not quite right. Yeah. Their Y positions are screwy. I think I did it upside down. So let's regenerate their positions and let's see if we can get this done. So first of all, the draw human command is upside down. That's my bad. So let's fix that one first. So let's go into VI visualize. And what do I want? I want Cairo. And then I want... Well, Vim is not just a strict superset of VI. Yeah, so it's pretty much the same. There are just a little things, some small things here and there that that bug me about VI. For example, when you insert mode in VI, Vim, it allows you to move around. And I don't like that. I don't like the ability to move around in Vim in insert mode. And there's some little things here and there that just I can't quite get used to. And so every time I try Vim, it just kind of drives me nuts. But it's just because I'm so used to VI. it is a better version of VI. I totally admit that. You should not learn VI if you know Vim. However, it's kind of my fault for learning VI instead. So it's okay. So we go to Cairo and then Cairo. Where am I? I'm over here, and we're going to go to cairoviz.cpp. We're going to pop down here to the last function that we created, which was draw human. Now let me see if we can get this foot position. So foot position is going to be position y minus height, and it should be position y plus height, because for Cairo, what we do is we count from top to bottom. So bottom's the highest, top is the highest. Head position is going to be position y minus radius. I believe this should be plus radius. And then this should solve the issue that we were just having. So now this should draw them downward. Now in terms of setting their positions, what we need to do, ED, I don't know what ED is, so I don't use that. Dodged a bullet there. Okay, so now let me go into init viewers, which I'm actually already in. So when we give them a position, which is defined down here, what we need to do is we need to say J, and then what we're going to do is we're going to take this value and we're going to subtract it off of the actual height. So what we're going to do is the following. We're going to say animation dot resolution y. Okay, so if we want 0, this should be okay. Animation resolution y minus this. So this is going to be the highest resolution, and we're going to continually subtract this value. This should draw the people in the right spot. So let's go over here. Let's make it. And then we're going to run 1 second /viral video. Okay, give it just a second to do its thing. Yep, there we go. And now let's run the last temp, Mirage. Go down 1. Okay, so now we have everyone drawn appropriately here, but they're still being cut off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many people are we running with? 100? Yeah. So we're definitely, we definitely have to get their positions a little bit better. So started out with Nano, but use Vim all the time. These days prefer Vim to VI. Yeah, totally fair. Sort of precursor to VI, but line-based editor. Oh, I guess it still has its uses for a couple of different cases, right? So let's see. We want to start at 0, and we want to count downward, right? So we start at 0. Then animation px dot, this should be okay. Yeah, this should totally be okay, because we're counting up in y to our animation resolution y. Yeah, this should be fine. Let me go here. Let's do another make. Let's run ./viral video, and then we'll check to see what we have. Okay, so now let's run Mirage. Go down 1. Okay, so yeah. Not really sure what is up with this one. Okay, so here's what I'm going to do. I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So here's what I want to do then. I'm going to add a small offset to both of these guys. And so this is going to be, let me think. How about we add in something called offset up here? So we will do offset X, and this is going to be equal to animation.resolution X times 0. Let's do 1. Let's do 10%. That should be okay. And we're going to make this a double. Okay, now we have to do the same thing for, oops, sorry for this. Oh my gosh, what am I doing? Undo. There we go. Remove this line. And now what I want to do is yank and paste. And we're going to do the same thing for X. So let's RX. Or RY, sorry about that, and then RY over here, and then we have our resolution. What image viewer is that? I'm using Mirage for this. It's kind of nice because it allows you to basically create a list of all the images you want, and you can scroll between them. So for people like me who do a lot of editing of images that let me see, a lot of editing of images that will eventually become videos, and these, you have like a large number of images, you can just scroll with that. They can reach arrow keys, Kappa. I do tend to switch between console and text editors for GUI and text editors though. Yeah, it kind of depends, I guess. So we have animation resolution X, and what I want to do is I want to subtract out the offset X. And I'm going to do the same for offset Y in just a second. Oop, that wasn't what I meant to do. And we're going to do the same for offset Y. And then what I want to do is I want to say, 0.5 times offset x. One second, I'm thinking here. I gotta think. This is gonna take some time. Plus this guy. Animation. Oop. And then this guy is gonna be multiplied down there. So let's see what happens if I just do this. Yep, something like this. Okay, that should do it. Now I'm gonna have to do the same thing down here. So we're gonna do 0.5 times offset y plus animation resolution y minus offset. Yes, minus offset y and add a parentheses there. And then I'll just multiply it by j. In fact, probably shouldn't. Oh, but I can, can't I? Yeah, I can do that. Let's do it over here. Let's go ahead and XX. 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 Let's go over here. Let's do make, and we'll run viral video. Yeah, my GUI text editor of choice these days is either TextEdit or some smarter. I use VS Code. What OSS now? OSS, open source software. Viral video. Give it a second to do its thing, and then we'll take a look. So now we have Mirage temp. Go down one. Okay, so now these guys are at least all in the image, but how many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Why do we have 21 people? That seems wrong. Let me see, how many people do we have? We have 100 people, I think, or 10 people. Wait, what? Wait, how many people do we have? Init viewers, anim, init viewer, int viewer. Oh, viewer number, we have 100. We have 100 people. Okay, so we have 100 people. However, thanks CVC. We have 100 people. However, only 21 of them are being visualized. So why is that the case? No earthly idea. They should all have positions. We've initialized them all, I think, correctly. So why is it an odd number like that? That seems bizarre to me. Yep, that's not 100. Okay, so what do we want to do then? Not sure. Okay, so how come we have 11 along the top? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's not right. So let me go down here and let's check the positions. Okay, so we're creating the positions in this way. We say viewers of i.p.x equals 0.5 times offset x. Okay, so what is our box size in this case? The box size is the square root of double viewer number. So maybe what's happening, maybe it's a quantum 100 and you just distributed the other 87 of them. I have no idea, no earthly idea. Programming text editors that don't worry about why 4coders even exist. Did you mention you use Windows 10? By the way, guys, is anyone else suffering from the flickering issue? If you are, again, put it on a source. I'm just curious to see if anyone in chat is currently running into it or not. Okay, so what do we have here? Viewers.p.x 0.5 times offset x. Okay, so this is fine. We give them an x position. We give them a y position. Then we say if I is equal to the floor of box size, where box size is equal to the square root of double viewer number. So what I want to do is I want to actually output this value here. So let me do an stdc out. Let's do box size. And line there. Right here, go over here, make it. There we go. And also what I want to do is go up to main real quick. And let's remove everything that we don't need here. So we need all this, but there's some things we don't need in this particular simulation. What are you using hardware? What are you using hardware 264 encoder in OBS? I'm using, let me see. Let me just go over there. OBS is over here. I'm using profile, settings. Output. I am using the X264 encoder. That is exactly what I'm using, but I think it's the only encoder I have, so I don't think I can change that one. I see flickering, as it's 10 a.m. on Saturday morning. I'm not too fully awake yet to care. Wait, where are you that it's 10 a.m. in the morning? That's not a typical time that people would watch. Let me see. So usually it'd be at night for people in Europe, or in the middle of the day for people in the US. Are you on the East Coast? No, West Coast, maybe. Yeah, I'm not familiar with West Coast time zones because I used to live in Central Time. I know no, there's no way that works either, because it is currently, oh, New Zealand. Yeah, okay. I know a couple people from New Zealand. Let me see. So, a couple of my friends are from New Zealand. In fact, it's kind of weird how many people are from New Zealand here at OIST. Anyway, it's kind of neat. Good. West Coast USA is a day behind. Yeah, I know that. So, because I'm in Japan, it's currently 6 o'clock in the morning my time, but it's like 4 o'clock in the afternoon yesterday for all of my friends in the US. So, yeah, New Zealand is actually just Australia light, according to what a lot of people say. Yeah, it's definitely when I stream, right? Like, I stream early in the morning because it allows me to kind of get up and do things. So again, I'm going to comment out things that we don't need. So let's see, I'm going to go ahead and remove this entirely. Okay, and now what I want to do is init viewers, and let's just comment all this guy out, and then comment all this guy out. Right, this, go over here, let's make that. Output a close. Fair enough, so let's go ahead and remove that too. Make that. Now let's check to see what we have from here. Mirage, no, I want to do viral video. Okay, now let's do Mirage. It says 10, it does say 10. So let's go down here, G. Oh, actually, I want to go to draw viewers. Where are we? Watch videos? Draw viewers. So in I less than viewers size. Is there something weird going on that I'm not familiar with? So it says that box size is equal to 10, right? Oh, I see the problem. Choose video. Where is our init viewers guy? I think I currently see it. If I equals floor.boxsize, that's not what we need. If I mod, yeah, I currently see the problem. Mod equals 0. Okay, so this means that anytime we are divisible by 10, oh, come on. Anytime we're divisible by 10, we do this. Okay, and the other issue is, I just realized, we're gonna need two different guys here. So J works down here for Y, but I'm gonna have to have another int in here for X. Let's see, J++, but we're also gonna have to set, let's say K equals 0 or something like this, and then down here we do K++. Yeah, something like this. So we'll do K++, there. And I think this should do it. So we're going to do int K equals 0. And then we're going to, instead of multiplying this by I, every time we see an I, we're going to want to add a K, so RK. And that I think should do it. So let's go here. Let's go to make. I mod floor box size. What? And value types int and double to be binary operator. What Windows Manager do you use? I use OpenBox, the Windows Manager. So what I want to do is maybe I divided by 10 equals 1. Something like this, maybe. Usually mod is used in this case, but I guess if I do double, floor box size should turn it into an int though. Make that. Double and double binary operator. Oh, the problem is the floor is going to be an int, I bet. So let's change this to int. Make. There we go, that would be it. So let's go viral video. Now let's take a look at Mirage, and hopefully this solved it. Nope, we only have one person now. Shoot. Totally broke it. Okay, let me see, what do we have here? We do K++. What's happening here? So K should be going up from 0 to 10. Let me just do an stdc out of K. Of K, and let's go in end line. 1 second. That needs to be an N. Let's go over here to make. Then we do /viral video. Okay, so we go 1 through 10. which isn't quite right. It should be, oh, but we're C-outing there, so it should be 0 through 9. That's okay. Any tips to use it, like recommend extensions to install? Not sure. Okay. Good luck, guys. I know nothing about Visual Studio Code. Man, we're taking so long just to get this done. Let's see, what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Viewers position.x is going to equal to. Looks like Visual Studio Code includes GitHub integration. Oh, good for them. Yeah, I mean, I can't imagine any type of sane person not having GitHub nowadays. Like, it's relatively difficult. So what I'm also going to do then is, instead of just outputting k, I'm going to output these. So I'm going to say viewers of i.p.x and viewers of i.p.y. And I'm going to add a tab in between because I totally forgot to do that. Tab. And let's see what happens. Right, this, go over here. Let's make that. Now we're going to do /viral video. Okay, so what do we have here? These positions are clearly incorrect. 10, 20, negative 340, negative 340. But this is the x positions. That's wrong. So how did it get negative all of a sudden? Oh, because k would be equal to 0. And in that case, j. I see. Okay. So let's say k equals 1 then. Yeah, so let's set k always equal to 1 and go to 10, I guess? But that's not right, because if k equals 0, wait, what was I doing here? P.x is equal to offset minus j times floor dot box size. Oh, let me just multiply this by k in the end. This is a silly way to do it. Let's go here, make /viral videos. Okay, so now it looks like they're all in the image. So let's just take the last Mirage, see what happens. Down. Okay, so we have almost all the people. For some reason, this guy's up here and these guys are down here. Not sure why this one's just so much better than everyone else. So let's go ahead and fix that one. The issue here is that we have this guy here and we say, and, 1 second, I not equal 0. So let's go to make. Let me see. What other version control system do people use other than GitHub? They use 2 other ones. One is SVN, and the other is CSV. No, CVS. So that's the 2 that they use. I always get CSV and CVS confused because they're literally the same thing. Well, like the abbreviation for them is like super close to each other. So, okay, so now I'm going to do the last viral video. And now let's take a look at Mirage. Okay. Oh, what are you doing over here now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dagnabbit. Yeah, but some people still use it, honestly. I found that out the other day. And there's also Mercurial. I've never heard of this one. And Bizarre, that just sounds bizarre to me. Haha. Is SVN worth using at all? Again, it's something that people will use, but I don't know if it's worthwhile using. Okay, so now what do I want to do? I want to say, viewers p.x, viewers p.y, and why did we have that extra guy? He just doesn't want to get in place. So let me see. If I equals 0, so basically if we go up to 10, we move down to the next line, right? So, we put them all on the same line. Wait, why is this happening? Mirage temp, let's go down here. Okay, so we want a box of people, but for some reason this guy doesn't want to be in that box of people at all. He just doesn't want to. So let's see what happens. We have first 10 people there. Okay, so now what? After the first 10 people appear, we have an additional guy number 11, which is actually guy number 10. I just realized. He's guy number 10, but he's the 11th person to appear because we're off by 1. Okay, so if we don't visualize that one guy up at the start, then we need to do 9 instead of 10? No, I feel like that doesn't solve the issue. Like, that doesn't help at all, because... Let me see. I have to think here real quick. So we're going through all the people, and we're going to visualize them. Firewall, what are you doing? I am visualizing basically an epidemic algorithm of how to propagate a video through the population, basically. That's what we're doing. So we have a video that people watch on YouTube or something like this, and then I have a small algorithm that basically plots the movement of this video across time, or across space. And what I want to do is just a very simple visualization of that. And that's basically where I'm at right now. So let me see. Bazaar was Ubuntu's and use Launchpad. Yes. So I don't know. I like Ubuntu. Don't get me wrong. It's doing a lot to popularize science, or not science, popularize Linux in a way. However, the truth is, it is not currently. I don't know. It does a lot of weird things with the community. You know, like it develops its own software. It doesn't work with the rest of the community, and it's kind of weird in a way. You know, I feel like it's It would be nice if they would just actively develop other things that other people have worked on, you know, but I guess that's fine. So we'll say times K. Okay, let me see. What do we have here? There's also Mac ports. I probably use Homebrew as my package manager. Yes, that is true. So let me see. See, I heard the other thing. See, I always heard to use Mac ports instead of Homebrew. Sorry, but I don't know. That was just what I used. But Mur is cool, man? Maybe it is. Okay, so what do we have here? So for the X positions, we go from 0.5. Now let me see. Why would we be doing this? So the very first guy, he should go from 0 to 10. And from there, we should be going from 0 to 10 consistently. So let me see. How about we bring this K++ down to the bottom of the loop. Paste it there. Yank here. And paste here. Move this guy up here. Let's see what happens now. Let's go to make. Now we're going to do a viral video. Let's go to Mirage. Okay, so now we just moved the guy over one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, what? 1, 2, 3, 4, 5. Oh no, that's 10. 4, 5. That's 10 down there. Okay, so this guy, no matter what, is not going to be in the right spot. Unless we start counting K at 1. Then we could solve it. So let me see. How about we set K equal to 1 to start? Why did I set it to R? 1. Let's go over here to make viral video. Now we'll go to Mirage. Okay, so now he's just missing. Shoot. Gosh darn it. Where is this guy going? He's at 10, but he doesn't have a Y position. Why doesn't he have a Y position? Where is that Y position? No, that's okay. He has a Y position. I'm an idiot. Let's see, 56, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, some guy's being plotted at 416. I have some sort of freaking... I don't know what. Okay, so let's change this back to 0. And now let's go over here. And let's do... make. Now we're going to do a.out. Or viral video. Take a look at that. So here's the idea. This one guy is off. And no matter what I do, he's going to be off. He's definitely going to be off. We should have 10 people. I'll be looking around, pretty busy today as well. Hey, thanks for coming in. We can use PHP framework called Laravel. I'm sorry. Okay, so what do we have here? K equals 0. Try K minus 1 in condition. Let me see. You want me to do K minus 1 in a condition. So we start with... Let me see. I don't think we ever get to K minus 1. I don't know what you mean by in a condition. So if we do if k, no, let me think. 1 second. If we start at -1. Oh, I see what you're saying. Put this at -1 here. And then, I would have to do a k++ in here. And remove this line down here. And then change this to -1. We do make. I don't think this is going to work though. I think there's something wrong here. Before viewers. Oh. Make. Viral video. Mirage. Yeah, okay. Why, what's the issue here? The first line has 11. That's the issue. You should not be using SE inline instead of... should you not be using nline instead of... No, I think the tabs are faster, right? So I think it's worthwhile. So that one didn't seem to work. Let me think. Let's do k = 0. Okay. And let's just count this out real quick. So we know we have 11 in the first batch. Why do we have 11 in the first batch? Because we start at 0. We start at 0. Okay. So we start at 0 here. Now we do k++ down here. Okay. So we go through. 1 second. imod int floor box size. Why don't we just do this at the count? So why don't we just say if k = 10. If k = 10. And let's go over here. Let's remove this one. Let's go down here and let's go here. And now let's do make and /viral video. Now let's go to Mirage. Temp. Okay, so we're still having the same issue. If k = 10. So we visualize at 0. Then all the other ones start visualizing at 1. I see. Okay, so we put the k++ at the start, then they all should start visualizing at 1. Let me see. So let's go down up here. We want them to start at 0. Let me see. So, okay, what if we do a k++ here? There. Add a semicolon in there. Remove this guy. We do right. Now we do make /viral video. And let's do Mirage. There we go. That did it. Fantastic. Good. Okay, so now what I want to do is I want to change this to a -1. So that everyone starts at 0. And change this to a -1. Now we go to /viral video. I'm sorry. Make /viral video. And now we do Mirage. Oh, one's off by 1 now. But why is it a perfect square? That doesn't make any sense to me. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, that's, I see now the problem. This needs to equal 9. Make. And then we're set. This took a significantly longer time than I was hoping for it to take. But there we go. We have 10 and 10. That's what I want. Just some sort of square lattice. And obviously this can increase in size. So if we do like 256, we should get 16 by 16. Let's try that real quick. Where are we? We are 100 people. Let's change this to 256. Oh, dag nabbit. This should be box size -1 is what it should be. Where's 9 here? Let's do box size -1. Now let's try this. Make /viral video. Now let's do Mirage. There we go. Got it. 256 by 256. Or 16 by 16. Works. Good. So that's everything I want. Simulus, why don't you use and viral video and open image viewer here? Because I didn't think about it. That would probably do it. Yep. I could also just put it in the make file, which is what I had been doing before. So let me see. And a viewer is here. So let's change that back to 100. Okay, so now what we need to do is a few more things. So what I'm going to do is I'm going to go back here, and I'm going to go to VI, visualization. One second, visualization. And let me think. So if we have 100 people, we need at least 100 frames for what I'm about to do here. So let's see what happens if we do visualization and... One second. I got to think. Cairo viz.h. And let's change this from number of frames 5 to number of frames. Let's do 300. Okay, run quit. Now we're gonna go into this guy here. Oh, actually, it's no, it's this guy. We're right. So let's go down here to draw human. And what I want to do now is I want to do animation dot current frame plus plus. Let's go over here. Let's do a quick make. Now we're gonna do ./viral video. Okay, all the images have been made. Now let's do Mirage, and let's see what happens. Okay, so what I forgot to do is make it so people people stay on the image. That's my bad. Okay, so how do we get people to stay on the image? Let's go to the draw human function and basically force it to be on all extra. One second, on all additional. Wait, I gotta think about this. Gotta think a little bit. Okay, so the issue is that these guys are going to change color at some point. So I suppose what the draw human command should do is it should, let me see, it shouldn't do animation current frame plus plus, it should do, wait, I'm trying to think here. We should draw, oh, up to current frame or something like this. So we should draw all the people up to a particular frame. So we'll say, for int I equals 0, I listen viewers.size. Wait, I'm not sure the best way to do this. This is okay, I'll worry about that animation a little bit later. I'm not so worried about that one for now. So for now, draw human will just draw an entire grid of people. I should really have them pop up because that kind of, I think, scared people in my last video. Okay, so let's do it again. So we'll say animation frame context plus plus. So we'll do animation dot current frame plus plus. Okay, so this increases the frame. So now what I need to do is every time I do draw human, what I want to do is, let me see. Viewers of I, we have, let's see, 100 frames or so. Let me see, what am I missing in chat? Open office. Parallels. Actually, what is Parallels again? Oh, Parallels is that thing that allows you on a Mac to open up another operating system. That's what it is. Okay, so we have draw human. Okay, so, oh, how about we have draw viewers, and then we also have animate viewers. This should do it. So now I have draw human. Draw viewers would draw a all the viewers, but I also want void function to draw all viewers and keep them successively. Okay, so now we're going to do void animate viewers, and we're going to want frame ampersand anim, and then we want std vector viewer viewers. Oh, this is going to take a lot longer than I anticipated. Okay, so let's see what happens. One with parallels VMware if I need full VM. Okay, so what I'm going to do, I'm going to say color white is going to be equal to 1111. There we go. And now we do for int I equals 0. Then we do I less than viewers dot size I plus plus. Pop down here, and we're going to say draw human of animation viewers of I dot p 10, which is the size, and then white, which is the color. Okay, So what do we have here? I normally just want parallels in VMware if I need want full VM. So nope, not that one. Okay, so now we have draw human. Now, okay, so this is gonna do exactly what the last one did. So now I want to do animation. Dot current frame. Plus plus. Okay, so now we have to solve this issue we just solved, which is how do we get all the people to stay on the screen? And that's going to be done. Let me see. So animate viewers is here. Let me go ahead and vi viral video dot h. 1 second, h, and let me go down to the draw viewers. Here we are there. Let's open up this and let's grab this guy. Put it here and add in a semicolon right here. Now let's go over here. Now over here. So what are we going to do to keep them on the screen? I guess what we're going to do is the following. So we're going to go through all the viewers, and then we also have an additional guy here. So let me add an R here because I failed to do so. Now we're going to say for int j equals animation dot current frame. Let me see. What do I want to do? Oh, I know what I want to do. I actually want this guy here. So let's go for int I equals 0, I less than animation dot current frame. I don't know. I guess we need a couple frames. So let's just go, the number of frames is going to equal to the number of viewers that we have. So we're just going to draw them all and then we're just going to drop them. That's okay. So we're going to draw human, viewers P10 white. Okay, so now what do I want to do? We have animation viewers P10 white, animation current frame plus plus. So we need a second loop to draw all the other humans. So we'll say, we draw all these guys. So I guess we just need a second loop, which is going to be for int I equals 0. Then we're going to do I less than current animation dot current frame. Sorry, j is what I need, plus plus. So let's pop over here. And now that we have these two loops, this should be everything that we need. So we're going to do rj, and we're going to do rj there. Pop this down here and add in a guy there. And now we want animation current frame down here. Add in a semicolon there. Delete this line. And I want to do this real quick and do this. Okay, so now what are we going to do? We're basically going to draw all the viewers up to J is what we want to do. And I think hopefully this will solve it. We'll see what happens. Maybe it doesn't. Let's go over here to animate viewers. So let me go over to the top. So we're going to do, instead of draw viewers, animate viewers. And now we're going to do make. It's probably going to break because I did something stupid. No, it did not. So let's do viral video. We have all the images being generated. So now let's go into Mirage Temp and let's see what happens. Okay, good. So they're all being generated and they all stay there. Great. Until the end there. Then they all stop. So here's what I'm going to do there. I'm going to say the following. I want to say for int I equals anim.current frame. Then we're going to say I less than 300. And we're going to say I plus plus. Pop down here. And we're going to say draw human for animation. Then I guess we want viewers. Oh, no, sorry, draw viewers for animation viewers. And then we say animation current frame plus plus. Okay. And let's go here to make current frame. I missed an R. Let's go here to make. Now we're going to do /viral video. Give it a second to do its thing. Then we're just gonna Mirage. So we scroll down, here's all the guys being generated. And when we get to about 100, let's see, 98, 99, 100, then they stay. Good. Okay, so they're there for good. all the last frames. So I am increasing a frame, not that you can see this, but it says 140, and we can scroll down, that's 299. They are all still there. Let me see, did I miss some chat? I think I did. Anyone else concerned that Simulix is going to create the Terminators in the next decade and will take over the world? No, you shouldn't be afraid of that, because any type of AI that I will create will be incredibly nice and friendly, like the nicest AI. We have the best AI in the world. I could not ask for better AI than what we currently have in the Quantum Systems unit. I do actually work with just robots, but that's okay. They have personalities, so it's pretty cool. Okay, so what do we have? Otherwise, I use Chrome and Firefox. Let me see. Did I miss anything? I didn't miss so much, I don't think. Also, let me just check online real quick on my channel. Here we have here. Okay, I just want to see if we still have the flickering after about an hour and a half, and it doesn't look like we do anymore. So maybe it's something that goes away with time. Okay, so Umbrella Corp styles? Yeah. Okay, so now we have the ability to draw all the people. Now all we have to do is visualize the people. How do I put this? We need to visualize the people if they have seen the video that we want. So let's go down and let's do that one. So now what we're going to do is animate viewers, and then after animating the viewers, what I want to do is I want to say if they have seen a video, they are actually going to be the color red. So let's go down to draw viewers. So what are we going to do here? We have draw viewers, and then all we have to do is put this main into a separate function, and that will be everything we need. So we want color white, and then we want color red. And this is going to be equal to, let's see, what do we want? I guess it's going to be red, green, blue, totally non-parent? Opaque is, I guess, the word I was looking for there. So now we're going to say color, and we're going to say human color, or viewer color. And just to keep with notation that I have been running before, I'm going to notate that as CLR, and that should be okay. So what I'm going to say is if viewer of I dot has seen 0 equals let me guess, bring home a homegrown American if you have red and white and blue comes next. Equals 1, so this means they have seen it. We are going to change the color to red, so we're going to say viewer color equals red. Let me just go ahead and set this equal to white. Else, let's go down here and let's say viewer color equals white. Then we're going to go down here and we're going to notate this as viewer color. Okay, that should do it. What are Text Wrangler and BB Edit like? I have no idea. Main. Let's go up here. Now, what do we want to do next? We are going to do this, and actually, I want to run the entire simulation first. So let's go ahead and do a DD here, and a DD there, and let's write this. Go here, and let's do a make. Okay, so everything broke, which is great. I love it when things break. So let's go to 335, and let's add a comma here. And white was not declared in this scope. Looks like it was. Let's go here, make. Okay, viewers of I is what I need there. S. Make. Okay. And I also want an equal sign here. Make. Now we're going to try it out. We're not going to run ./viral video. Give it a second to do its thing. Taking some time, but that's okay. Generate all of the images, and now let's do the Mirage. Scroll down, all the people are being generated, fantastic, and good. Okay, some people have seen the video too. Great. Okay, so now we have everything we need to do the first visualization, which is going to be drawing an entire group of people, and after drawing the group of people, we then basically watch the video propagate through space and time. There we go. First visualization almost done in 1 hour and 30 minutes. Getting there. Okay, so what are we going to do then? We have all the necessary functions, so what I want to do is go up here. And honestly, guys, I am going to basically take this entire... Oh, I forgot to close the output at the end. This entire function here, I'm going to comment it out for now. So let's go ahead and do this. Comment it out. Ooh, that wasn't what I meant to do at all. Comment this guy out. There. Comment this guy out over here. because this is no longer going to be main. Now what I'm going to do is I'm going to, let me go here, set number. And we have 28 to 62. What is 28 minus 62? This is going to be, oh gosh, I can't do math right now. 62 minus 20 is going to give you 42. Minus 8 is going to give you 36. So I'm going to yank 36 lines. Now I'm going to pop down here, and we're going to go to the first function here, which is visualize small network. Set no number. And we're going to paste this. There we go. So this is our dude guy. DD here. Now let's go ahead and remove things that we don't need. Let's go here. Animation.init. So we don't need the output stuff. So let's go ahead and DD there. We don't need output viewers here. DD there. 1 plus 1 equals 2. You're American? Of course you don't do math. Yeah, thanks Slayer Darth. Appreciate that one. I'll have you know that we have the best math in America. Oh gosh, gosh. Don't get me started on the election. I'm not going to talk about it. It's not happening. Ah, gosh. Anyway, let's do it. So number of videos equals 1,000. Fantastic. Oh. Here's what I'm going to do then. I'm going to say I less than, this is not what I want. Choose videos, and here's what I'm going to do. Provide videos, choose videos, watch video, and then after watch videos, I'm going to put in here draw viewers. Okay, and in here I want animation and viewers. There we go. Yeah, I actually never watched that show. What was it? Breaking Bad? Yeah, I never saw it. The first episode really just kind of screwed me over. I did not like the show after that first episode. So I don't know, it wasn't really my thing. American equals right, everyone else equals wrong. That is generally true, but there are a few exceptions. For example, there was that one time. No, I think that's generally true. Yeah, I think that's generally true. Yeah. Okay, so what are we going to do? Let's go ahead and animate the viewers up here. So provide videos after here, and let's animate the viewers here. So let's do animate viewers, and we're going to say animation dot and viewers. There we go. Let's go down here, remove this one, and we have to drill the frames at the end. Had to watch the pilot episode for some college class. Oh, I see. Okay, so what do we do? Animate viewers, and then we're going to say I less than 100, but we don't want I less than 100. What we actually want is I less than animation, 300, which is number of frames, so let's do num frames, plural? Structure for videos, viral video, CPP, dagnabbit. Let's do VI, visualization, Cairo, and then Cairo viz.h, and num frames is correct. Okay, let's go here, num frames, and we're going to say I equals animation.currentFrame. Now I know what you're thinking. Could you see the animation current frame for this? And you would be right. But I don't care. Let's go here. So now we can remove these guys. Okay, so now we should have the first visualization basically done. So let's go ahead and bring this up to the top. What was that? Oh, oops, I accidentally run the code again. I don't know how I did that one. So let's go up to the top to main. Main. And I want to visualize small network. So let's go here and let's do visualize small network. So we're going to do visualize small network. Here we are. And we're going to want an int viewer number, which we're going to say is 100. Go here, there, everywhere, and let's do a make. Dag freaking nabbit. I need 397. Animation and viewers with a comma, not a period. Commas, periods are better than commas, period? I don't know. I don't know anymore. Let's do viral video. Give it a second to run, and now let's see what happens. I'm also quite passionate fan of radio, so I use TuneIn Radio quite a lot. Oh, interesting. For me, the best two American shows are Sopranos and The Good Wife. I forgot to do animation draw frames. Try it again. Viral video. Okay, I'm trying to consume more radio content than television content these days. I'll be honest, radio television content is kind of nice in a way because it allows you to still do your work while doing other things, you know? So let me go up to the init viewers. And let me remove something. Oh, come on. Init view somewhere in here. There we are. I want to remove the output that I've been doing. So let me see. Here it is there. And I want to remove this cout statement. Now let's go over here and let's run Last Mirage. Okay, so we're going to scroll down. All the people are being generated exactly as we want. Okay, so we start with these people. Now let's see how this propagates. Eventually more and more people watch. Eventually though, I don't think too many more people watch. Oh, there we go. That's neat. Okay, good. This is about what I expected. So again, so this means that in the end, we have basically about half the population watching our video, which is great. So now we have a couple more things that we want to do, a couple more visualizations. Obviously this one doesn't look so impressive now because we have the constant set a little bit weird, but it's okay. It is exactly how we would anticipate it going. Because again, if you guys were watching previously, the way that we're doing this is basically, it is a poll network. We're grabbing stuff from YouTube. So what do we need to do next? Well, next what I want to do is give everyone some sort of force integration. So we're going to add in the Verlet algorithm and we're going to go from there. So if you guys don't remember what the Verlet algorithm is, it's an algorithm. Here, let me pull it out real quick. I just don't want to accidentally give you guys the wrong information, which I have done before on accident. Again, I really don't mean to give you guys false information. It just happens sometimes. Okay, so what are we going to do next? So we have to pull out the Verlet algorithm stuff, but I don't really remember where I put it. Let me see, creating color quantization, Verlet, here it is. Good, good, good. Vivaldi length equals US. Let me see, what is this? Open link? Sorry about that, guys. Oh, this actually looks quite sweet. Yeah, I like that. There's one browser that I really like. It is called LuaKit. I really like LuaKit. Just because you can very simply open it, F11. You can open things with O down here, and you go to like reddit.com. It's super neat. I don't know. I really like LuaKit. And the coolest thing is if you press F, you get like these numbers, and then you can say like, I don't know, you go to 440, and then you just say, okay, well, we're gonna check out link 440 or something like that. I don't know, it's just kind of neat. And then open up tabs, you could go to twitter.com. I don't know, it's a neat browser that follows VI bindings. For those who don't know Algorithm X, it's an algorithm. I'm sorry. You could probably quote me with a whole bunch of, in fact, back in the day, people used to kind of quote me a lot with really, really bad quotes. Okay, where is my, here it is, Zernal. Good. Hey, Neopiece, what's up? That looks cool. Oh, it's called LuaKit. And it uses Vim bindings. That's the cool thing about it. And again, there are some things that are weird about it, like, for example, and I'll admit, here, let me just go ahead and show you something about it. Let me open up LuaKit. Let me go to google.com. Okay, and now if I want to type in here, I can do one of two things. One, I can click, and then I can just start typing. The other thing I can do is I can press the I button to insert, and then I say, hey. Right? So that's kind of nice, because, you know, it has you can press the I button to do that, and also by pressing Shift F, I believe. Yeah, so then I can go to like 20 or something like this, and then it should bring me to 20. I don't know why it's not, but you can also do like help, I think. Yeah, so help is something. Then we also have history, which maybe I shouldn't show you guys. Then we also have you can see how few times I actually use this browser nowadays. Obviously, you can delete these tabs by either clicking on them like you would normally do, or you can delete the tab, I think with D? Yeah, D deletes the tab. Anyway, there's a whole bunch of little bindings here and there that you can learn. I think it's all in help, probably. Then I think there's also bookmarks. bookmarks. Something like this. Yeah. So here are all the bookmarks that I have. Good. So I don't know. It's nice. It just has a whole bunch of nice things about it. I really like it. Yeah, I really like it. It's a shame though. I don't use it as much as I could. I want to use it more, but for some reason something keeps dragging me away and bringing me back to Chromium. I don't remember why. Why do I keep using Chromium? I don't really like it that much. Yeah, why am I so stuck on Chromium? I don't know. I think I'm just going to start going back to using LuaKit for a bit. Huh. Thanks for that, guys. You guys are awesome. Okay, so now let's go and talk about new page before, the Verlet algorithm. Okay, so what is the Verlet algorithm? Go rhythm. Okay, so what is the Verlet algorithm? That is a good question. Okay, so here's what we do. Taylor series. Expansion. So for the basic, let's say, kinematic equation, Taylor series is the following. We'll say x is equal to x, whatever it was before, plus the time derivative of x, which is the velocity, times t. I guess this doesn't necessarily have a not, plus acceleration, 1/2, acceleration times time, which is the double time derivative of t. Then we do plus, let's see, 1/3 bt cubed or something like this. This is actually a sixth, so on and so forth, higher order terms. But these don't matter. The ones we care about are x, v, and a. We're going to ignore higher order terms for now. Now what we do for this algorithm is we say r, or x, of t plus delta t. So the next time step is going to be equal to r of t, so its current position, x of t, plus v times delta t. 1 second. Plus a, 1/2 a times delta t squared. And I apologize that my t's look a lot like my pluses. We're also going to say the following. We're going to say x of t minus delta t is going to be equal to x of t minus v times delta t plus 1/2 a delta t squared. Okay, so adding these guys together, we get the following. We get x of t plus delta t is going to be equal to 2 times x, oops, sorry about this, x of t. Then we do, 1 second, I might have to scroll down just a little bit so you can see this. Sorry about that. 2x of t. Then we subtract out, 1 second, x of t minus delta t. Okay. Then we add in a delta t squared, because the two velocities cancel out when we add them together. And this way we have a way to get the next time step for our position, simply by taking into account the acceleration and the previous position. And that's about it. We've done this algorithm before a couple times, and it's super straightforward. Does everything that we needed to do. So that's great. This is everything that we need. And of course, if we need to find the velocity, which we may at some point, we can add the velocity back, simply by saying the velocity is going to be equal to x of t plus delta t minus x of t minus delta t. And then we go over here to delta t. We're doing the next visualization. Again, we've got a lot of visualizations to do. As I said before, this might be a bit of a longer episode. It's Saturday, so I don't have necessarily work to worry about. But yeah, it's probably going to be a bit of a longer episode. This guy, what we're going to do is we're going to have everyone attracted to each other based on their affinity, right? So in this way, we have something kind of like a self-organizing map. We'll initialize everyone in some sort of starting position, which is going to be the grid, and then we're going to allow them to kind of mingle a little bit. And I guess we'll create a function called mingle. Yeah, why not? We'll call it mingle. I don't care. And then we'll go from there. And then after this visualization, the next visualization, we just assume every person is a pixel on an image, and we do the same thing we did last time. So we have the 3 big visualizations done. And then after that, we have to do one final visualization, which is a visualization of a push and pull network in and of themselves, and I don't really know how to do that. So we'll see what happens there. I'm kind of excited, but at the same time, I kind of feel like maybe I should have thought about it more before doing this. But hey, who cares? It's Saturday. Did you ever consider becoming a medical doctor? I did, actually. I'm sorry, I was lost in thought. Those were the days when I used to watch House all the time. No, but the truth is, the reason I wanted to become a medical doctor was not genuine, you know? Back in high school, I was super worried about what people thought of me, you know? Because somehow or another people had a positive opinion of me and I didn't know why, and I felt really, really, really bad, you know? And so what ended up happening, that's why your handwriting's terrible? Ha 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 ha. Thanks, man. But yeah, so I did want to become a medical doctor. My handwriting's not that bad. This is legible. And to be fair, guys, I'm writing on this, and this is nice, but it's not the best, you know? My chalkboard writing is much better than my writing here. In fact, my chalkboard writing is probably my best writing. As sad as that might be. Anyway, but yeah, so back in high school, I was super duper worried about what people thought about me. So I wanted to do a profession that people saw as good, you know, they saw as incredibly useful, you know? I wanted them to say, hey, I knew this guy who became a doctor and he was super important and did all this kind of stuff. And I don't know, so when I left high school, I, on the one hand, wanted to be an author. That's totally true. I wanted to write. That's what I wanted to do. But then I figured I can do the writing when I'm, you know, retired later on. So, you know, there's no reason to rush that. And so what I did is I signed up for an EE degree, electrical engineering, and I also signed up to be pre-med. So I was both pre-medical and electrical engineering. And then I took my first physics course, and I just fell in love with that, and I just decided I would do physics instead. But there was a time there when I was doing pre-medical physics. In fact, in my degree, at the end, I took enough biology courses that I could have done pre-medical physics. That's what I could have done. But I just decided against it at the end and just went with physics because, I don't know, the pre-med was not interesting to me. Not that biology in and of itself is not interesting, just not for me, you know? And this is true for a lot of people, you know? My channel is not interesting for a lot of people because we do physics and we do programming, and I get that, you know? I get that people are interested in different things, you know? And for me, biology just is not something that I don't wake up in the morning. I don't automatically want to feed fish and cut up cadavers. This isn't something that's interesting to me. What is interesting is, I don't know, what I was doing before. Plasma research, quantum research, stuff that's just like intrinsically interesting problems that you can apply math almost directly to. This is so cool because it's like, man, you see the logic behind it and you can figure it out. And I don't know, it's just, there's this huge back and forth. It's a bottom-up process where we start from math and we move to reality, rather than the other case where we observe reality and we try to model it, which is, I don't know, it's just a different idea. Anyway, so I did want to become a doctor because I knew that doctors were successful people. But in the end, I realized being successful is something you have to quantify. If I end up hating my job, there's no reason for me to do it. And I realized because I was such a big social recluse, I don't know, having to deal with patients just seemed like the biggest nightmare imaginable. Anyway, that was kind of a side topic, but it's true, it's true. Okay, so now what do I want to do? We have the viewers, so let's just go ahead and go over here, and let's do we need to create a couple different functions, so I'm going to go into VI viral video. 1 second. Oh, that wasn't what I meant to do, that's the binary .h. Oh, that was a .hjh. So now what am I going to do? I'm going to go down and let's go ahead and create a couple of new functions here. So we're going to say function to find all the accelerations for all the folks. And we're going to say void find acceleration. Okay, so what are we going to do now? Because we have a way to basically define their XY position, this should be okay. So what we're going to do is find the acceleration of an individual viewer. So we're going to say viewer ampersand individual, and then we're going to say std vector of viewers, and we're going to call it viewers. There we go there. And then we're going to have to do the last one down here, which is function for the Verlet algorithm / updating position change. Okay, so now what we're going to do is the following. So we're going to say void I guess we could do update positions or something like that. I don't know, what should we call this? Relay, I suppose is what I called it before. Yeah, we'll do relay. That's okay. And what do we want? I suppose... let's do this on an individual viewer. Individual. At this point, we should have all the accelerations found and everything, so this shouldn't be that big of a deal. Now, obviously, we've done code much like this before. This is not anything particularly new, so let's pop this down here. So again, we have the visualize small network done. Now we just have the visualize large network and visualize moving network. The one that we're currently working on is visualize moving network. My expectation is that I will be finished with this in about an hour, maybe an hour and 30 minutes. So guys, if you want to leave, I totally get that, because we are about to end my typical stream time. I've got a feeling that the viewership is going to dip a little bit in the next few minutes as 7 o'clock rolls around my time. So we'll see what happens there. On the one hand, maybe it'll all be fine. On the other hand, it doesn't really matter, you know, because in the end, the way I see it, today we're just kind of making visualizations and stuff. So it's kind of more of a chill, relaxing day. If you guys have any questions, comments, concerns, again, doesn't necessarily have to be related to what we're doing right now. Feel free to let me know, and I will totally do my best to answer those questions as soon as I see them in chat. Okay, find acceleration. Let me go over here, right and quit, and let me go back a directory, ls. Let's go into vi, ... and I want to go into Kuramoto. Now I want to go into, one second, Kuramoto. Oh, it must be how to dance.cpp. Now let's do find acceleration. Good, I have the same function here, and this is basically what we have here. So what do we have? Auto member group. X difference is equal to member position minus Steve position. So basically we find the acceleration of everyone in the group. And this should be okay. So we'll find the acceleration of every individual, and we have all the other individuals, all the other viewers. So let's go ahead and do the find acceleration first, and then we'll do the relay algorithm. So what are we going to do here? So we're going to say for, oh, you know what we can do? We can just do this in int. Let's do this in int. And let me just very quickly go over here, vi viral video.cpp. Let's go down here, and let's just change this to an .h. Let's go down here, and let's change this to an int. Now let's go CPP down to the bottom, and there we go. So for I equals 0, I less than the viewers dot size. Then we're gonna do I++. Pop this down here. Okay, so now what do we want to do? We're going to basically create find how far off we are from the other person, right? So what are we gonna do? We have the individual. So we're going to say if I not equal to individual, here we are there, we're going to keep going. So what are we going to say? We're going to say, yeah, so we're going to say, wait, yes, okay, so now we have to find a couple different guys. So let's go up here and let's figure out what we need. So we need distance, so we're going to say double, one second. That was not what I meant to spell. Double distance. And I guess we'll just call it dist. Let's go over here and let's define that distance. So we're going to say distance is going to be equal to square root of the x's minus the x's and the y's minus the y's. So we're going to say viewer of I dot position dot x minus viewers of individual dot position dot x. Okay, so this is the x's, and we're gonna have to square this. So let's go ahead and square that. And so let's go ahead and grab this guy here, and let's just multiply it by the same guy that we just had. So viewer position x. And then what we need to do is we need to x plus y, x squared plus y squared equals z squared, right? So then we're going to have to add in the following. So we're going to say add plus, and I'm just going to copy this for now. Copy this, paste it here. That wasn't what I meant to do. That. Paste. There we go. And add in a parentheses there. Now you might be asking, why are you not using power? That's a pretty good question. The reason is just basically hearsay. I don't know why, but like when I was learning coding again in college, my old advisor used to use Fortran 77, and he said always multiply when possible instead of using power, because multiplying is faster. So I was like, okay, I'll do that. And since then, I've always done it, you know? Okay, so we have the position X's, we have the position Y's. This should be okay. So now what do we want to do next? And actually, guys, I'm going to, just to make the formatting a little bit nicer, add a space here. And I'm going to add another space down here. Okay. So what's next? What is next? That is a good question. So we have the distance. So now what we have to do is find the acceleration. So what we're going to say is viewer of individual dot acceleration. And how about we have this equal to some sort of 1 over r squared type of guy? Yeah, that sounds good to me. So we will do... So the problem with 1 over r squared, it's super oscillatory. So what we should probably do is have it 1 over r squared with some sort of velocity too. That's what we should do. Have some sort of guy there. So we're going to do... what do we want to do? For now, let's just do 1 over distance times distance. There's our 1 over r squared. And then we're going to subtract out a little bit for the velocity. So we're going to say viewers of individual. There we go. Dot velocity. And let's just pop this down to the next line. I realize that this is super long, and I apologize for that one. Velocity. Okay. And what I did before is I multiplied this by 0.01. So let's do that too and see what happens. Okay. So now we're going to do the Verlet algorithm, which shouldn't be so bad. Let me see what I do over here. I think it was just Verlet. There we go there. Okay, so we did Verlet there. Next, Verlet here. Okay, so what did we do? We went through all the members of the group. Sounds good. And we updated all of their positions. Okay, so let's do it. But we have just one individual here. Maybe what I should have done... No, it's okay. We'll just do for one individual. So we're going to say... individual dot velocity. Oh, I'm sorry. Position dot x is going to be equal to the following. So what do we do? Oh, position. Oh, wait, 1 second. I have to think here. I just did something really, really stupid. Viewers dot acceleration. Oh, yeah, I just did something stupid. Let me think. What we should really do is find an acceleration.x and an acceleration.y, which should be splittable. Yes, okay. I just did something really stupid. Let me go up here. Let's see, what do we want here? We have the acceleration.x and the acceleration.y. So, I guess what I'm going to say is the acceleration.x is going to be equal to dist.x and dist.y. So let's go here and let's change this to vec. Vec here, and let's say dist.x. And let's actually just remove all of this for now. Just remove all of that, because that was all just me being stupid. So let's do x, and oh, that didn't work, did it? Whatever. Oh, it's d end or something like that. No, what is it? It's d to the end of the line, and that's going to be d shift there. Okay, so now we're going to say dist.x is going to be equal to viewers of I dot position dot x minus viewers of individual dot position dot x, and then we do the same thing for y. So let's add a semicolon there, yank paste, and let's change this to a y. So ry, then we find the next x, and we do ry again, find the next x, ry again. Okay, so now we say acceleration dot x is going to equal to dist.x. 1 second. Oh gosh, what am I doing? Here? Oh, that was what I meant to do either. Dot x. Let's go here. And let's do viewers.individual velocity.x. There we go. So now we're going to yank 2 lines and we're going to paste 2 lines down here, and this is going to be the same for y. And I realized, guys, I could have changed this a good bit. I could have done some, I could have done a lot of things to make this a little bit easier to read and stuff, but that's okay. It's fine. So we have the acceleration changing based on the velocity in the x and y direction. So now we have an acceleration in the x direction, and acceleration in the y direction. So let's go down here and let's say individual.position x. 1 second. Is going to be equal to, what do I want it to be? It should be, well, it should be basically what we have up there. So it's going to be 2 times individual.position dot x minus, 1 second. And what I want to do also is I want to go up here and I want to say vec temp. Yeah, this should do it. So we're going to say temp is going to be equal to, oh, let's go up here and let's say equals to individual dot position. Okay, now we say individual dot position dot x, and what do I want to do here? Minus member dot previous position. Let me think. Do they have a previous position? Yeah, I guess they do. So we'll say individual dot previous position dot. Oh gosh, I guess I didn't use position, did I? I just did p. So move these two. Let's remove these two, and these two and these two. And then we'll get down here. We'll remove these two over here. Previous position dot x plus individual dot acceleration dot x times dt times dt. Let's pop down here and let's say a times dt times dt. Okay, so now we know we have to read in a dt in here, double dt. Good, we'll add that back in a second. Now we're going to say individual dot pp. Let me go over here. Is going to be equal to temp. So that was its previous position. Okay, so that should be okay. So now what do we have? Member.position equals 2. Member.position minus member previous position. Sure, acceleration dt dt. Sounds good to me. Now we have to update the member.velocity. So we're going to go down here. We're going to say individual dot velocity dot x is going to be equal to individual dot position minus individual dot previous position dot x. Hey Frank, what's up? No, I'm not interested. Dot x. I don't care about cars, like literally at all. So previous position dot x. Let's do an rx here. Individual previous position dot x, and then we're going to divide by 2 times dt. Add that there, yank and paste, and we're going to change this to a y. There, there, and there. Okay, now obviously, we could have done this in a number of different ways with some different operators and things, but that's okay. I really don't care about girls either, so could we? I don't think it's particularly worthwhile to talk about. Okay, so what do we do here? Let's go ahead and write this. Go over here. Let's make it real quick. Make. Just make sure it makes. I was not declared in the scope. Let's go down to 420. There we are here. For I equals 0. I forgot to put an int. That was me being an idiot. So we're going to go through all the viewers, find the acceleration. This should be good. And now what I want to do is go up here real quick to the very top. And I want to go down to init viewers. No, I'm not in it for the guys either. I just don't really care about that kind of stuff. So let's go down to, what do we want? Viewer number there. Good, so this is where we define all the positions. So what I want to do is I want to say viewers position.px, py, and then what I want to do is the following. Oh, that's their position, right? Yes, that is their positions. So now what I want to say is viewers of I dot previous position is going to be equal to viewers of I dot position. Let's go over here and let me see, pb minus temp. What is this? Operator minus, let's go to, oh, sorry about that, dd. Let's go ahead and fix the other lines too, which is going to be in 436. There. I accidentally have a position here, which is great. Let's go ahead and remove that. P. And what do we have over here? We also have a minus instead of an equals. So let's do that. Individual.previous position equals that. Okay, good. So now we should have everything set. Let me just go very quickly into viralvideo.h, go down here and add a DT. So let's do double DT. Let's go here. Let's go ahead and make it real quick to make sure it works. Make, and let's go from there. Physics says nothing about reproduction, actually. That's probably more biology than anything else. Variable double height set but not used. That's okay. So let me see. Let's go to chirovisualization.cpp. VI, visualization, Chiro visualization dot, what are we doing here? CPP. Let's go to 115. Body height. Looks like body height is not used, so let's go ahead and remove these lines. Right, quit. Let's make it. Hey, Luminian, what's up? No, don't worry about it, man. I'm actually going to be streaming for a little bit longer. What do you mean? It just said that it wasn't used. Dagnabbit. Let's grab this. Go to current visualization. Let's go down to 115 and let's add it back. Okay, so let's make that. It's going to say it's not used, but it is used. It must just be in an if condition statement or something like that. Okay, so now what are we going to do? Let's go ahead and right quit here, and let's go to viralvideos.cpp. Let's pop down here. Dagnabbit, yep, I might have just said that. Sorry about that. So let's go to find acceleration, and now we have to do visualize moving network, for which I mean, no, I do not mean that. I do not curse, and that's also, please don't curse on stream. So what do we have here? Let's go ahead and grab this guy, and let's put it up here. So visualize moving network, here. Okay, so let's see what I want to do. We'll have anime viewers for this one. This should be okay. And now we have the find affinities. That's all okay. I noticed, which was fine. Okay, so let's do watch videos, choose videos, draw viewers. Okay, good. So now what do I have to do? We have to draw viewers, which changes all of their positions. So now we go from there. So provide view videos. Frank, please do not talk about anyone in my family. Sorry about that. I don't like people necessarily knowing about that stuff. So let's go here. Watch videos, draw videos, draw viewers. So now what I need to do is the following. So we have to find all the viewers' acceleration. So let's do that real quick. So we're going to do draw viewers there. And at this point, what I'm going to do is I'm going to say find acceleration here. And I want to do the following. So we're going to say go through all the people. Frank, shut up. Gosh darn it. Okay, so let's go from here. We have choose videos, provide videos. So what I need to do now is I need to basically update everyone's position and stuff like this. There's absolutely nothing I can do about Facebook. I can't keep people, like, I don't know. Anyway, sorry. Okay, so now we have to go down here and we have to update everyone's position and go from there. So what are we going to do? Provide videos, choose videos, watch videos, draw viewers. This is what we have so far, and this is the previous function that we have. Now all we have to do is update everyone's positions. So what I probably want to do is put the find acceleration and the Verlet algorithm kind of together into their own function, which basically say update positions. So let's go down here and let's do function to update positions every time step. So we're going to do void update positions. Okay, and it's going to be viewer ampersand individual. Viewer. We want std vector viewers. Okay, and let's pop this down here. Now, what we're going to do is basically go through all the viewers and update their position accordingly. So this function is going to be relatively straightforward. It's just going to be for int I equals 0, I less than viewers.size. Then we're going to do I++. Okay, so now we're going to go through everyone, and we're basically going to update each of their individual positions and stuff like that. So what are we going to do? I guess we will say the following. We will say, we have the find acceleration. I suppose that needs to go first. We're going to find acceleration of the individual. So we're going to say I, and then we want viewers. Okay. Then we want the next one, which is going to be, what is it? Verlay. Of, and I suppose I want viewers of I. And that should be that. Okay. So this should be everything we need for that. And so let's go ahead and pop this up here and let's update positions. Position, and we want viewers. Let's go over here. Let's go into vi viral video.h. One second. And let's go ahead and add the find positions here, update positions there. So grab this and there. Do you need the ampersand? One second. I probably do. Let me see. For the function, let me see. Do I need the ampersand? I do in this case because of the way I wrote the function. However, let me see. Did I miss an ampersand? Let me see. Viewers, I think I have the ampersand. Yeah, I think I have the ampersand everywhere. Oh, find acceleration up here. My bad. Let me see. I do need one here. There. Let's go over here. Find acceleration. Viewers. Okay. Thanks. Now let's go to G++. I'm sorry. Make. Viewers of I, two view arguments, and Verlay. Let me see. What did I do for Verlay? I also need individual and double DT. Oh, so I guess we'll do DT. So I guess in update position, we should also read in a DT. So double DT. Go down here, add in a DT. And then I guess when we update positions up here, we'll add in a DT of 0.1. Now let's go over here and let's make that. Too many arguments in function, of course there are, because I forgot to update over here. G, A, DT. Make. DT has not been declared. Of course it hasn't, because I'm a complete idiot. Let's go over here. A, double, DT, make. Okay, that one made. So now what we need to do is run this and see what happens. So let me go up to the top and let me see. So I have visualize moving network. Let me go up here and let's change this to visualize moving network of 100 people. Okay, so now we're going to make that real quick and we're going to run that one. /viral video. Give it just a second to do its thing. I'm actually not quite sure what it's doing right now. Maybe I should output something so I could tell what it's doing. Okay, it's making the images. Good, good, good. So now we're going to go into the last mirage. And let's see what happens. So we scroll down, here's all the people being generated, and then they just move ever so slightly, and that's it. That's not quite what I wanted. Yeah, that's not right. Nope. Yep, that's not what I wanted. Okay, I don't know what's happening there. Okay, so let's go down to G. Do you take into account the chance of the video being shared more than once depending on the original viewer's audience? It can be some blogger or popular Twitch streamer. Yeah, so it is possible for people to share more than once. But basically, the way I see the sharing is it's basically sending the video out to random partners. So like they'll share with like, I don't know, like 4 people or something like that. And then the next time they share the video, they share it to another group of people or something like that. So at the very start, we start with 10 subscribers or something like that, which is a large number of subscribers. I'll totally give you that. But yeah, so now let's see if we can figure out what's wrong with these positions and go from there. So where's your W error and W pedantic? I'm sorry. Pedantic is what I meant. Okay, so let's go to velocity.x, velocity.y. Everything else should be good. Find acceleration there. And let's see, what do we need to do from there? So what we need to do is we need to clear here. And let's see. Find acceleration, relay, update position. So there's something wrong with how we're updating the position here. So we're going through all the people. We're updating all the viewers of I and DT. So why do the positions just dramatically shift like that? They shouldn't, but they do. And let me see. So the positions then, Oh, I see probably I think I see the problem. Okay. So what I should do instead, let me see. So all of their positions, they initially start. Okay, wait, I gotta think here. No, all their initial positions are okay. Yeah, they start out, okay, so that's fine, never mind. I was being stupid there. For some reason they all stop at 0 though. That's weird. I don't know what's happening with that shift though. I don't know why that happens. Okay, so let's see what we have. Let me go through and let's see if we are actually updating the accelerations. So let's see, update position. And in update position, what I want to do is just put in the accelerations here. So let's go ahead and do an stdc out. And let's do individual, or viewers of i.acceleration.x and viewers of i.acceleration.y and line. And we're going to put a tab into here. Okay, right over here. And now let's do the last make, run viral video, and go from there. Viral video. Okay, so these are all the accelerations as they're changing. Note that Control C. I'm not exactly sure what we're outputting here, but we do have an infinite here, which probably shouldn't happen. Yeah, that really probably shouldn't happen. Why does that happen? Oh, I know why that happens. So let's go up here. Views.acceleration. The reason is because distance is not what I mean to do. So let me see. The distance is that. Let me see. Wait, I gotta think here. So one of the acceleration in Y, for some reason, is going to be infinite. And the acceleration in X is going to be super duper small, which is okay because of the dt. Well, I know the dt should have nothing to do with this. So it's going to be one of the distance squared, the other of the distance squared. The only way it's going to be infinite is if, let me see, relay vectemp individual double dt. So what are you going to do? Individual.position.x is 2 times individual.position.x. Yeah, that should be okay. Yeah, that should be fine. Right? That's what I have written down, right? Let me see. R is equal to 2RT. Yep, minus individual previous position. Yep. Plus acceleration times dt times cd. Yes, exactly what I have. So the position should be okay. So let me see. What would the other problem be? Let's see if we can figure out this acceleration thing. So the acceleration thing, the only reason it would be infinite is if we are dividing by 0, right? So the distance.y would have to be 0. So if I is not equal to individual, then we should never have a situation where they're actually in the same place at the same time. But also I just realized that this isn't quite the best way to do it. I wanted to attract people based on their affinity to other people. So I've got a bit of a problem in that I don't currently, yeah, okay, so I have to think now. So they all have affinities to everyone else, and this affinity is a double value. So I guess what I'll do is I'll just multiply their affinity value here, and then they'll have a distance. Yeah, so that should do it. So this is what I'm gonna do. I'm gonna go over here, and then I'm gonna say viewers of individual dot affinities of I, and that should do it. Divide by distance here. Okay, there we go, that should do it. So depending on how closely related they are. And then we'll do the same thing here. So we'll remove this and add in this line here. Okay, and so this should slow them down. Now this should attract people to other people. But we now have another problem in that somehow we are still with an acceleration, an infinite acceleration. So this could be for a number of reasons. Let me go ahead and go up to init viewers. And let me see what happens. Init viewers is up there. Let's pop up one more time. Okay, so now what I'm gonna do is init viewers is there. And Frank, shut up. Okay, Let's go from there. Visualize small network. Draw viewers. What are we going to do next? Where was I? I was going to go from there. So where are we? We are watch video here. Choose video there. What was I going to do? Dagnabbit. I need to attract people based on their proximity and also based on their affinity to people, right? So we have to find accelerations. What I need to do is set their velocities equal to 0 at the very start, such that they don't have initial velocities. So let's do init viewers, which should be up here. And now we're going to set all of their velocities equal to 0. So viewer index. Now what are we going to do? K++ viewer number. Yep, this is what I want. So now we're going to say viewers of I dot previous position, or I'm sorry, dot velocity. Let me see. Dot x is going to be equal to 0. And we're going to do the same thing for y. And I think we should probably do the same thing for acceleration. So let's go ahead and do yank to yank, and we're going to paste down here. And we're going to say viewers of I acceleration. And we're going to go down here. Oh, sorry about that. U dot acceleration. Okay, so now we've initialized them all appropriately. Let's try this one more time. Make. And let's go for it. So we're going to do viral video. Okay, so now we've broken everything. Control C. Everything's broken. That's good. Yep, that's good. So that's their initial velocity and acceleration. Somehow, though, they're not being updated. And I'm not exactly sure why. So let's do viewer here. Viewers. Find acceleration. Int individual. Let's see. SCD vector. Or individual. Vector viewer viewers. Vector distance. Int I equals 0. I less than viewers.size. If I not equal to individual, so that means we're not the individual that we're talking about, we are now going to say viewers p.x minus viewers individual p.x. That's going to be our distance in x. Yeah, so why on earth would our acceleration be 0? That doesn't make any sense. Viewers velocity.x, unless I'm not updating the velocity. But it looks like I am. So let me see, velocity is previous position. Let's see what happens if we don't print anything out here. So let's not print this out. Let's go here and let's make it. Then we're going to run it real quick and let's see what happens. So we're going to do viral video, give it just a second to do its thing, and let's see what happens in the visualization. For some reason, I've got a feeling they're all just going to, they should all stay in the same spot, but for some reason they're all going to move a little bit, and I don't know exactly why. So here we have the images being generated. Let's do the last mirage. Here, let's scroll down. We have all the people being generated. Yeah, so they're doing the same thing as last time, where they just pop over there, except for that last line, which doesn't make sense to me. And then they just, yeah. Dagnabbit, why do they pop over there? What is forcing them over there? Okay. Let's go over here and let's see. So update position is here. Find the acceleration, then the Verlet algorithm. We're going to say individual at position.x is going to be equal to 2 times. Oh, you know what? I forgot to update this for y too. Yank to yank. Paste. So position.y, ry. Individual py. Let's see. Dot. Individual py. Dot. And individual acceleration y. Dot. Okay. So now for find acceleration, maybe I did something stupid like that too. Dist.x. We do update the acceleration in y and the acceleration in x, and they are just dependent on y and x. That should be okay. So individual.velocity.x, this should be fine. So let's see what happens if we do right here. Go here, let's make that. And let's see what happens to these guys. I'm pretty sure they're probably just going to be, it's going to be much similar to what we just saw. They're just going to be like shifted or something like that. And I'm not exactly sure why this is happening. Because I haven't had this problem before. So we'll see what happens. So let's go to Frank, shut up. So now we're going to Mirage image. Scroll down here. Okay, so now they're all forced in the same position. Yeah, we're done. Okay, so now what we're going to do is, let me see. Individual velocity.x, individual velocity.y. I guess we can output their positions, but this isn't really going to help that much. So let's just go down here, update positions. Let me see. We can output their accelerations. What else do we have here? We have a couple other things that we can update. But yeah. SEC out viewers I acceleration X. New tab viewers acceleration Y. Let's just check out the accelerations again. So let's go here. Let's make it. And let's do here. Mirage. Nope. Viral video. Yes. Okay, so they're literally all nans. Dag nabbit. They're all either nan or 0, and they definitely should not be 0 because the distance.x. Dag nabbit, what is happening here? So let me go up and let me just output a single time step. So let's go here and let's do visualize moving network. There. Pop down here, visualize moving network, viewer number. Instead of doing this for loop, I'm going to yank it and paste it, and then I'm going to comment this line out, and then I'm going to say for animation current frame. Instead of num frames, I'm literally just going to do animation current frame plus 2. Let's go over here. Let's make this animation. I misspelled so many things in that one. Let's make this, and let's see what happens. Give it a second. Viral video. Okay, so they're all nans. Okay. I don't know why it's still going. This should have definitely stopped by now. Okay, then we get a seg fault. Well, that's significantly different than what I was anticipating. Let me go down here. Let's remove the SDDC out. Let's go to make. Viral video. 1 second. Let it do its thing. Why? What just happened? Oh shoot, I know what happened. Dag nabbit. Okay, so let's go to animation current frame here. And I know exactly what happened. So what I'm gonna say is 102. Now let's go over here. Let's make that. Let's go down here, G. And let's do this real quick. Okay, so now let's make it one more time. And now let's run /viral video. Okay, give it a second to do its thing. It's creating all those images, although that's not necessarily necessary. Okay, so let's see if we get these accelerations to be something other than what they are right now. Okay. Oh, maybe this is correct. So it could be. Yeah, okay, so maybe this is correct. That's fine. So how about this? What I'm going to do is animation draw frames. I'm going to remove that line for now, just to get these guys moving somewhere. Let's go here, move those guys. Now, acceleration Y, here's what I'm going to say. I'm going to say if, let's see, viewers of I dot, I'm sorry, viewers of individual. Let's see, viewers of individual dot affinities of I is greater than 0. We're going to pop down here. We're going to do the following. Okay, so this just makes it so we don't do unnecessary calculations. And then we go ahead and get these guys set up. Okay, so maybe this is correct. Maybe we just have an incredibly small distance here. Or how do I put this? Maybe we just have an incredibly small acceleration. So now we have to figure out why all of their positions are being forced into particular values. So I think actually the accelerations are fine. I just think that a lot of these acceleration values are, for some reason, 0. Or 0 because they're affinity. They just have no affinity to that person. Which is okay, I suppose. Okay, that just means that they haven't seen any of the same videos. Which is fine. Okay, so now let's go ahead and write this. Try it one more time. Make here. And let's do /viral video. Okay, so now we have something significantly different, which was not expected. Yeah, this is. Oh, I think I know another problem. Let's add a plus equals here, and a plus equals there. That should solve that issue. So now we're gonna say find acceleration, and we're basically going to say here. Before going into this loop, I guess we'll say, let me see, we should probably initialize everyone's, let me see, for all the viewers, we're going through all the viewers. Oh, I know what we should do. We're going to say viewers of individual, let's see, dot acceleration equals 0. Okay, let's try this one. Let's make this acceleration, I'm sorry, equals, let's just do dot x equals 0, paste, and dot y equals 0. Make. Give it a second to do its thing, and now let's do viral video. Okay, so this is a little bit different than the last one. Now we have a lot of infinites, and I don't know why we're getting these infinites. The only reason why we could get these infinites is if the distance is equal to 0, which means they are at the same location, which they should never be at the same location. So I don't exactly know why this would be the case. I guess what I can do is, let me see. Why would they be at the same location? Because we're ignoring the individual himself, right? Or him or herself. So under no situation should they be in the same location. Yeah, I'm not sure how to fix that one. So let's see. Okay. Guys, I'm gonna check real quick on my stream, just to check something. Okay, so what I wanna do is remove this here, and we'll be good from there. Okay, so now what do I want to do? We have I equals 0, I less than viewers.size, I plus plus. This means you're going through all the different viewers, right? And guys, if you have any questions, comments, concerns, feel free to let me know, and I will totally answer those questions as soon as I see them in chat. Outside of that, thanks for watching up to this point, guys. Sorry about Frank, and we can go from there. Okay, so now the question is why? Why is the distance in x or in y equal to 0? The only case where they could be equal to 0 is if they are at the exact same location. So I guess, man, why would they be at the exact same location unless they're the same person? Let's go ahead and take a look at what's happening in the image itself. So let's go to animation draw frames, and let's actually draw the frames this time. You know, if they have an infinite acceleration, they're obviously all going to be dragged to the top. Let's see what happens. Let's go here, make. And let's do viral video. Give it a second to do its thing. And now let's do the last Mirage, which should be right up here somewhere. There it is. Okay, so now we're gonna scroll down. We have all these guys. Okay, and once we get to 100 here, okay. So note exactly what happened. Some of the people didn't move, or they moved very, very little, and other people just got shot to the end. And those people are the guys who, for some reason, have a distance to someone else that's equal to infinity. And for that, I'm not exactly sure why. It could be. I have no idea. It just seems like a random number of them are just for some reason tossed up to the corners. And I can't figure out why. Let me see, why would that be the case? I see no relation. None whatsoever. Okay, can't figure that one out. So let's see. Yeah. I'm sorry, I can't figure this one out. For some reason, some of the viewers are, let me see. So reading an int individual. The int is going to be some sort of integer value, right? So we're going through all the different viewers, and our int value is going to be I that we're going through. Are you doing relaxation? No, I'm basically just trying to get all of these people to be attracted to each other. Yeah, you could call me a matchmaker, I suppose, or something like that. Anyway, point is, I'm trying to get them all to come closer together, you know? So if they have a high affinity to each other, if they've all watched the same videos together, then they'll be attracted to each other in this particular simulation. But for some reason, I can't get that to happen. So let me see. They have all the accelerations, and for some reason, some of the people's accelerations is like, yeah, okay, you're right. Everyone's acceleration, for some reason, some of them are just infinite, and I'm not exactly sure why they're infinite. So let me see. What are we gonna do? Find acceleration here. Okay, so in the acceleration, if they have the same position with any other person in the network, but they shouldn't have the same position with anyone else in the network. Let me just go down and let me just see out a couple of different guys. So I'm going to say if dist.x, let me see, dist.x minus dist.x equals 0, or dist.y minus dist.y equals 0. I'm going to output two different things. So I'm going to do stdc out, and I want to see out individual, and I want to see out new tab and I. Okay, let's go over here and let's see. I don't know, that's what I'm trying to figure out. Let's go to make. Okay, now we're going to do Mirage here. Viral video. Okay, let's see what happens. So, 93, 92, 91. Yeah, Frank, seriously, shut up. Okay. Okay, so what are we gonna do? So literally every single number has certain ones. Try y minus y equals 0. I did both. Let me see, what do we have here? Find acceleration. What do we have? Visualize small network. Where was I? Find acceleration. Yes, so that's literally what I just tried. Y minus y equals 0. Okay. Oh, shoot. Yeah, this is totally right. Yeah, this is totally definitely right. Yep. Let me think. No, I know exactly why. I now know exactly why. This is totally fine. Let's go to Mirage Temp. The issue is I have this split up into acceleration X and acceleration Y. And obviously, everyone along this line has the same X position, and everyone along this line has the same Y position. So that would mean that, I don't know why it's random, but I do know that at some point, we should run into a case where everyone has the same acceleration, or the acceleration, or the distance in Y and the distance in X is going to equal 0. Yeah, so I know why now, because they're all along the same line. So what I'm going to do then is go down here. Yeah, I gotcha. So let's go ahead and remove this guy here. DD. Oh, I see what you're saying. Yeah, that one is always true. But I do see... Okay, you're right. That one's always true. I see what you're saying. My bad. I should have just done if dist x or dist y is equal to 0. So then I'm going to do an ampersand here. And let's do, drop it down here, and we're going to say dist.x not equal 0, and dist.y not equal 0. Right, this, go over here and let's make it. And I think this will do it. So now let's go to Viral Video, let it generate those images, and now let's go to Mirage, scroll down. And we should have, come on, don't go away. Oh, they still went away. Where'd they go? Okay. So, okay. Where are they going? Dag nabbit. Just the people don't want to be here anymore. But I'm new. It feels like I have to watch the recordings. Yeah, so here's the idea. We've been working on this for the full past week, right? So basically the idea is we're propagating a video through a population of people, right? And we have been doing it for the entire past week, so there is a little bit of stuff to catch up on, but it's not so bad, right? If you look up epidemic algorithms, you'll kind of get the gist of what we're doing, and if you don't mind, give me just a second to pull out a paper, which will definitely give you the idea of what we're doing. Give me just a minute. I have a lot of papers over here, a lot of which are not really necessary, but a lot of which are. What would I have done with this one? Did I put it? Oh, I have no idea where I put this one. Oh, dagnabbit. Maybe I'm an idiot, and maybe I shouldn't have said that, because maybe I can't find the paper I'm looking for. I should have linked it under my stream, but I just didn't, because I didn't think about it at the time. That was my bad. Okay, so let's see, what do we have here? Fitzhugh Nagumo model, that's not worthwhile. Fuzziness, self-organizing map. Fuzziness again. Is this epidemic algorithms? No, where is the epidemic algorithms? It should be back there though. 1 second. Give me a second. Here we have that. Nope. Nope. What is this one? Nope. Fuzzy logic again. Which, by the way, I spent a little bit too much time learning about fuzzy logic. That was fuzzy. Because there's like a relation between fuzziness and quantum mechanics, you know? Like, they're quite similar in a lot of ways. Okay, I can't seem to find the paper I was looking for. Oh, wait a minute. Nope. No, that's not it. Nope. Sorry. No, I can't seem to find it. Let me just Google it real quick. Let's go over here and let's pop up to introduction maybe to epidemic algorithms. Okay, so let's see, what do we have here? Introduction epidemic algorithms. It's probably that one. 1 second. Let's pop this one up. See what happens. Okay, so I think this is it. Yeah, this is it. Good. That's the one I was looking for. There you go. So this one gives you a good information on epidemic algorithms. It's really a pretty good guide. Okay, so sorry. Oh, is it really? Hey, 959. I'm trying to figure out a subject to write my thermodynamics essay for. Any suggestions? What does the thermodynamics essay have to be about? Because there's actually this really cool algorithm in thermodynamics known as the... Oh, what is it called? It's in my thermal physics book. It's, oh my gosh, what is the big, thermodynamics, shoot. What is it called? I can't remember. Metropolis algorithm, maybe? Let me see. Maybe it's a Metropolis algorithm. Let me see. Is this algorithm Markov chain Monte Carlo model for obtaining a sequence of random sample property distribution? I'm not even reading the sequence. Can be used to approximate a distribution, generate a histogram, or compute an integral. Metropolis Hastings. Let me see. No, this isn't quite right. It can be related to anything, but it has to be related to thermodynamics. Well, the thing is, thermodynamics is like super duper broad, right? I mean, you could literally do probability theory and it would still be thermodynamics, right? Because in the end, you go from the basics, which is going to be your probability theory and stuff, and then you move on to the more complicated stuff from there, right? So there's a lot of stuff there. Maxwell's Demon is cool. You know, that's a pretty neat one. Then but I'm pretty sure like everyone probably chooses Maxwell's Demon. I don't know really. There are definitely some cool thermodynamics algorithms out there. This one, for some reason, I'm pretty sure. Metropolis. Yeah, maybe this isn't the one I was thinking of. Sorry about that. I don't remember the algorithm I was thinking of, but that's okay. There's so much from what to choose from. I'm thinking entropy for different matter phases. It's not going to be very long, just 5 to 10 pages. Entropy for different matter phases. Yeah, that's pretty interesting, right? I mean, you've got like, yeah, that's definitely interesting, I think. That falls from, so there's certain relations, right, for the entropy and stuff like that. Dealing with derivatives in, oh gosh, I don't remember. I used to have it all remembered, but I don't remember it anymore. Sorry about that. But it's pretty cool, right? There's a whole bunch of stuff to talk about. Thermodynamics was one of my favorite classes. So let me go down here and let's print out the accelerations one more time, and let's see what happens. So I'm gonna go here, remove those, write this, go here, and let's do make. Okay. So now what we're going to do after making, we're going to run fire video again, and let's take a look at these accelerations. So all these accelerations seem fine to me. Yeah, those all do not look like nans or anything. Oh, 1.19 e to the 11th. Thank you for sharing. I'll try to catch up with you. I'm studying computer science there. However, awesome stream, awesome idea. Thanks, man, I appreciate it. Okay, so here's the issue. Some of these guys are times 10 to the positive 10. which would mean that they're close enough to 0. Okay, I see. So if distance y not equals 0, let's say greater than 0 point. Let's say greater than a cutoff. Okay, and we'll say greater than cutoff. Okay, and now up here we'll say cutoff is going to be equal to, am I doing the acceleration right? I feel like I'm not. So we'll do x squared plus y squared equals r squared. That'll give us the r squared, right? And that'll give us an acceleration. And how do we go back from the r squared to get the x and y? We could multiply by unit vectors. That's one way to do it. Are we allowed to split up the x and y in this way? I don't think we are. We have the distance. Let me see. So we have the distance. Oh, maybe what we need to do... It's okay, let's just do it. 0.0001. Let's go here. Let's make that. Let's do this as a double. Make. Were you able to figure out the algorithm you're talking about? I think it would be interesting to study about. It would also be kind of original for our class, I guess. So I honestly think the one that I was thinking of was the Metropolis algorithm, now that I think about it. But I don't remember why this was in my Thermo book. If you don't mind... Oh, my Thermo book is out. Let me take a look. Yeah, okay, so let me see. What do we have here? Metropolis algorithm should be... Let me find M. Metropolis. Yes, 347. Let's go there. Okay, so I think this is for quantum stats, actually. 1 second, 347, that's where I'm going. Okay, so what we have here... Oh, it actually goes through everything. Okay, so what they're doing... 347. Okay, it says here, a better idea is to use Boltzmann's factors themselves as guiding during the random generation of subset of state samples. Yeah, so it's in the... I found it in the Introduction to Thermophysics book. I have that book. Oh, yeah. So this is the book I was talking about. Sorry about that. I missed that one. It actually goes through the pseudocode right here in the book. So it is on page 349. Totally goes through that. It's incredibly interesting, or at least it was when I went through it the first time. But I don't remember it very well. This is the icing model there. And then I think... No, it's just the icing model that it goes through. But, yeah, it's definitely in the book. But definitely look it up, because it might not be as related as some of the other stuff, because he starts going into kind of like quantum stuff in the end there, which is not quite as related as other things. But I gotta admit, I love this book. This thermal physics book is quite good, in my opinion. Of course, that is fine. Okay, so now let's go from here. We have all of these guys there, and now let's see what happens if we scroll up. Okay, so we still have these guys. Oh, I didn't run it yet. Let's go to you. Here. Viral video. See what we have up here. Okay, so we have some people with 0 acceleration, which is fair enough. And now let's go to, let's see. Viral video. No, I want to go to Mirage. Let's scroll down. Here we have all the people being generated. And, okay, good. So they officially are not running away now. And this is simply because at some point, because we're dealing with doubles, I'm fairly certain that they were like subtly off from each other. And so I had to create some sort of cutoff, which is fine. Okay, so now let's see what happens if we keep going from there. Isn't Schroeder about a cat? No, Schrodinger is about the cat, Frank. Okay, so we have relay, update position, find acceleration. Good, so we have all the accelerations found. The only issue is that these accelerations seem to be quite small. How small are these guys? Yes, some of them are quite small. So what I need to do is increase our DT. So let's see, what do we want with the DT? Let's change the DT to 1. So where we visualize moving network, and let's just go ahead and do the whole network. Let's see what happens. XX, remove these guys there. 0.1, let's change this to 1. Let's go here, make. Schroeder, yeah, he's the one that published the book. Vec dist. 460. Double vec. Make. Give it a second. Now let's do viral video. Oh shoot, I shouldn't be outputting stuff. That is my bad. So let's go down to find acceleration, or G down here or something. Move this guy. Let's go to, yeah, okay, well, it's making the images anyway. Those were super quick. I've got a feeling that we did something stupid. Okay, so these people just randomly leave. That wasn't what I was hoping to find at all. Shoot! Why are they leaving? I have no idea. Why on earth would these guys be leaving? And the other guys aren't moving at all, by the way. Oh, there's some people that are moving. Okay, so they started moving at the end there. But other than that, they didn't really move at all. Okay, so why would they just be shooting out like that? I just finished schematics for my linear algebra thesis. Oh, pretty cool. So let's go up here. Let's... Oh, no. We want the cutoff to be... Let's make the cutoff 0.01 for now. Let's go here. Let's make that. Frank, seriously, man. You really need to learn... Gosh darn it, man. Okay, so let's go here. Let's make it... Now let's go to viral video. Give it a second to do its thing. And we'll go from there. Okay. So what are we going to do next? Once these guys are generated, let's see what happens. We're going to go to Mirage. Scroll down. We have all the people being generated, which is great. And some of them still disappear. Yep, some of them definitely disappear. Some of them move. This guy's moving the wrong direction. Yep. Not really sure what's happening here. Dagnabbit. Okay. So, yeah, I'm not really sure. I'm not really sure at all how to fix that one. All I wanted to do was have people kind of organize together based on their affinities to each other. But for some reason, this isn't working. So let me think. Let's go over here. Page, new page before. Okay, so here's what we're going to do. We're going to say force is equal to KQQ over R squared. This is your typical force here. Let me see. The main important thing is this R squared. Let me go ahead and circle that in red. This is kind of how far away you are from the other person. For our purposes, this is basically just a constant that we're setting equal to the affinity. Okay? So this R squared value, okay? Somehow our forces are becoming incredibly high and other ones are incredibly low. So this is why at some point they're just kind of forced off the map. Okay. So that means the R squared value has to be incredibly, incredibly small. So let me see. How would they have the distance? No matter what, it's going to be in pixels. And so under no circumstance should the distance be less than 1, I think. Well, I guess there's a few circumstances where it could be, but for the most part here, shouldn't be less than 1. I think. Let me see. When we output the positions, what do we set the positions to? So the positions, so let's change this cutoff to exactly 1. Let's do 1.0. And let me scroll up to the positions and let's see what we have here. So the positions are, let me see. Vector position dot x is going to be 0.5 plus offset times animation resolution x. So offset x, animation resolution x, offset x over box size times k. Yeah, so it looks like they have integer positions. So let me see. Let's do make again. Okay, and now let's do Mirage. You're okay. Don't worry about it. Keep asking as many questions as you want. How comes that you are broadcasting such awesome stuff? I never expected to find something that interesting. I thought I'd just find more game dev. So last year, actually, there used to be an entire section on Twitch for programming. Nowadays there isn't. It's kind of all related to each other. And these guys are not moving. Oh, they are. Yes, they're moving. Okay. So the issue here, let me see. I know the issue. I have to multiply the acceleration by an arbitrary constant. Anyway, so a year ago, there used to be a group that used to just do programming on Twitch. In fact, the only reason I found out about Twitch is because I went to a subreddit called Watch People Code. And that subreddit was showing people live coding, and it was super cool to me. So I was like, oh, I'll just watch people do coding. And then as time went on, it was like a whole bunch of web dev stuff. And I was like, okay, web dev is okay. I don't mind watching web dev, but one thing I didn't enjoy watching was game dev. But at that time, programming and game dev were separated. You have game dev up here and programming down here. Now, because we're on Twitch, game dev is always going to be more popular than the other alternative types of programming, right? So then what ended up happening was, I decided to do programming in the programming category, right? And that's what I did. So I did programming in the programming category. It was great. I really enjoyed doing it. I got, a lot of people to help me out with my code, and I've been getting successively better at programming. Then there was this big switch to creative where they pushed programming and game dev into creative. People started using hashtags, and everyone who did a game dev hashtag also did a hashtag programming. And this is okay, but it made it so the programming category, which used to be exclusively programming, not necessarily game dev, got overwhelmed by the game devs, which made it so, well, it was less common to see someone just doing programming. And at some point, most of the programmers who were not game developers just kind of stopped streaming because they couldn't get a viewership. And that's kind of what happened. So in some sense, yeah, I don't know. I've been streaming for a while, and I kind of do it because, I don't know. I think there is merit to this. Like, this is the type of stream that I enjoy watching. Just someone learning stuff, someone figuring stuff out. This is fun. But a lot of times game dev isn't quite as fun. Frank, we're not bullying you, okay? The issue is that every single time, you come in here, Frank, you literally just troll people. And it is incredibly annoying. You should know better. And this is why I keep getting rid of you. Okay. So guys, this is what I'm gonna do. Because we currently have pretty much everything set here for the moving function here. And all we have left is one last visualization. Here's what I'm gonna do. I'm going to go ahead and change the acceleration guy and multiply it by an arbitrary factor. Let's say 100 for now, just to make sure that we can see people move. And then what we're gonna do from there, yeah, I have both tags, but at least I'm doing more programming than scripting Unity or some such. Yeah, I mean, I'll be honest, there's nothing wrong with game dev streams. Obviously, there's absolutely nothing wrong with it. And certain streams are very fun to watch. But these are streams for me that have a whole bunch of programming. Like a lot of programming. That's fun. Watching people do, like, I don't know, draw figures and stuff, this isn't fun for me. And that's kind of the thing. This is why live coding is now a thing. So here's what I'm going to do. Individuals does affinities. I'm going to multiply this by 100. Yeah, let's multiply this by an arbitrary factor. So let's just say 100 times this. And let's just see if this fixes anything. 100 times that. Okay, let's go here to make. And let's see what happens here. Okay, so now we're going to do Viro Video. Give it a second to do its thing. And then we will go from there. Okay, so at this point, it's just going to be tuning, I believe, to get this function to work the way I want it to work. But that should be okay. So let's do Mirage. Scroll down. We have all the people being generated. And here they are all flying all over the place because their accelerations are too high. But we should... Let me see. Yeah, so their accelerations are way too high now. But we at least see them all running away. That's good. Yep. Yep, that's good. Now, the question I have is why is all of their acceleration always necessarily in one direction? And I know why now. Good. So that's another thing I have to fix. And this is going to be, I have to create a quick sine function down here. So we're going to say, we'll say double sine of double x. Let's go down here. We're going to, one second. If x is less than 0, we're going to return -1. Then we have else if x is equal to 0, we're going to return 0. And then we say else if, we'll just say else. One second. We're just going to return 1. Let's go here. And let me go into viral video dot, one second, vi. Go down to the bottom here, and we're going to add in g. We're going to add in this last function. So let's go over here to here, and we're going to return the sign of a double. There we go. Let's grab this guy, bring it up over here. There, and let's add a semicolon there, write this. Let's go here, let's make it. Let's go over here and let's return sign of distance.x. So we're gonna do sign of dist.x times 10. And then we're going to multiply this by viewers. Sorry about the formatting here, guys. It's kind of messy. There, and we're gonna do sign of dist.y times 10. And we'll multiply that by viewers. Yeah, it's super messy. I'm terribly sorry about that, guys. It's okay, that's how it is. Sign, y is this down a line. Let's go down to the bottom here, x, there. Let's go here, make that. Frank, it's not that you're asking stupid questions. That has nothing to do with this. It's the fact that you stalked my Facebook every single time you get on here. You literally just troll people. There is nothing else you do. You have made fun of Gustorn, you have made fun of me, you have made fun of everyone else on this stream. You are definitely annoying people. And you should know better. You have 25 different accounts. No, Frank, quit this. Okay, so let me go here. Guys, if Frank pops up one more time, I definitely apologize, but I'm gonna close my stream. I'm sorry. This is super frustrating for probably everyone involved. I apologize. See, the issue is we can't ban Frank because he's got 25 accounts, you know? And I can't do anything about that. I've sent in reports, that's it. There's nothing else I can do. So, that's it. I'm gonna make that, I'm gonna run viral video. Let's run that. Okay. Yeah. I guess it's really the only thing we can do. Okay, so let's go here. Let's go to Mirage. Scroll down. Okay, so now, oh, they're still all moving that way. Why are they all still moving that way? Distance.x should be able to be negative, shouldn't it? Let's check. Let's see, so sign of distance.x, let me see. What do we have? We have negative and we have positive, but they're all still moving the same direction, which to me is weird. You would think that some of them would be moving upwards. Okay. I think it'd be easier just to ignore him. Yeah, maybe. Nisimiko, please, though he has been annoying, please refrain from making comments like that. Okay, so this is what we're gonna do. We are going to figure out why these guys are not returning. Let's see, so we have -1 here, +1 here. Here's what I want to do. I'm just gonna see out something here. SCD, see out, and I want to see out -1. New line, and yank this. Paste it down here, and see out 1. Let's go over here, and let's do a make. Viral video. Okay, so these are all just 1. None of them are -1. Okay, so why are they all just 1? Let me see. Dist.x is going to be minus viewers individual px. Let me see. If we flip these guys, they should be... Yeah, so let's flip these guys. Let's say minus... wait, 1 second. Minus viewers p.x here. And let's go here. Okay, so we're going to do this one, and then we're basically going to copy that guy over here. So let's go ahead and copy this. Okay, and let's see what happens. And go here. And let's make that. Let's see if we can get these guys to be -1. Viral video. They are all still 1. Why are they all still 1? Let's see. So it's going to be G else. So if X is less than 0, this means that X is always greater than 0. But it shouldn't be. Viewers of individual.p.y, p.x. Let's output X. So let's do stdc out X. Oh, that was what I meant to do. I guess this is okay. Tab. There. Let's do this. Let's do here, make. And let's see what happens. Okay, let's do viral video. These are all positive, aren't they? But why are they all positive? I feel like they shouldn't all be positive. Position.y, position.x. Viral video. Viewers of individual p.x, p.y. Why are they all positive? Let's multiply 1 by a negative sign. No, that's not gonna work. Let's just copy this and let's do this. Copy this here. There. And let's go back to the start. This should, in practice, mean viral video. Oh, that was what I meant to do. Make viral video. Yeah, so these are all also positive. But why are they positive? Dagnabbit. We should have some that are negative. Because we're subtracting 2 different values, and these 2 different values are on either direction. Distance.x, this is just, yeah, sine of distance.x. Yeah, I have no idea. I have no idea why this would be. It's checking if the value to increment is positive. Let me see. It is checking. Let me see. It is checking. Let me see. What is it checking? It is checking whether distance.x is positive or negative. Which should be okay. If viewers of individual affinity is greater than 0. No, the affinities. No, we should definitely check the distance. We are checking the, yeah, so we definitely need to check the distance. Because the affinities is always going to be a positive integer from 0 to 1. Or positive, I'm sorry, positive double from 0 to 1. So, we'll see. Okay, so I don't know why then. Why would it all be... It shouldn't be positive. I don't understand. So let's take a look at what we have here. Let's go to the last mirage. Scroll down. Okay, so we have guys here. They're obviously all running away this way, which is fair enough for now, except for that top line. That top line's not moving at all. I don't know why. So they're all running away. Okay, but they're all running away in the same directions, either down or to the right. However, if you look at this, the distance between this guy and this one here and this one here, and the distance between this one and this one should be opposite, right? Yeah, they should definitely be opposite. And because we're squaring, we're not necessarily going to get that. So distance x and distance y, distance x, viewers of i.p.x, viewers of individual p.x, viewers individual p.y. Return 0? Why are they all positive? Distance.x. I guess I'll do this. Let's go ahead and remove these COUTs here. That one there. And let's just see out distance.x and distance.y. New tab. New line. Let's go over here. Let's make that. And then let's check to see what we got. So let's do viral video. Okay, so these, Control C, definitely have negatives in them. See? Negative, negative. These are negative. If distance.x is greater than cutoff, got it. Yep, you got it. That was it, 959. Let's go to viral video. Let's check to see what happens after we draw all the images, and we should see people moving all about, which is exactly what we want. Then after that point, yep, you're right, you're right. So now let's check to see what this one does. Let's do Mirage, and let's scroll down. We have all the people being generated, and yes, they're all going all over the place. Exactly what we want to see. Fantastic. Okay, that's actually quite cool for a number of reasons, but that's okay. And what we can do is we can force them onto the walls of the box if they need to be. But that's okay. I'm not going to worry so much about that one. Okay, so that is that. So now we have them moving all about, which means they can form their own self-organizing circle. However, I believe I need to do something up here. So let me go ahead and create a double retardation equals 1. Let's call it, maybe I shouldn't call it retardation. That has a negative. Let's call it damp. There we go. So now we're going to say minus damp here. And here. Now let's go here and make it. And let's see what happens. Let's go to viral video. Give it a second to make, and this should have the people moving a little bit slower. And they have, it's basically a dampening force based on their velocity, such that the acceleration is not so high. I mean, with this, we have 2 out of 3 visualizations done. Now, let me check something real quick. So let's go to Mirage, scroll down. Okay. Oh. Wait a minute. I might have had this. Why are they? They're moving faster. They're definitely moving faster. Except for those guys. They're stuck in place. Let me see. Maybe we need to make this super small? No, that doesn't make any sense. 1 second. So the acceleration... The acceleration minus the dampening force. That's what you always do, right? 1 over r squared. What? Is this not right? Let me think. So let's change this to a 0.1. Make that. And let's do a make. I just did that. Viral video. And let's see what happens. So actually, guys, I think I'm going to close the stream relatively soon. We got 2 out of 3 visualizations done, and the last visualization is a visualization you've already seen, just with many, many more people, so that every person is a pixel instead of what we saw before. So let's do a Mirage. Scroll down, and let's see. So these guys are... Oh, I see. Okay, well, it seems they're moving a little bit differently. Yeah, they're definitely moving differently. This is okay. This is okay. So we'll figure out what to do from here. Maybe it can't be greater than 1? Not sure. Okay, so I don't know exactly how that's going to work. We'll figure that one out. Because I don't think we're moving at all right now. So obviously if we multiply this guy by 0, and we go over here, we do a make, we just get the acceleration based on, we just see the acceleration, right? So we do viral video. And let's go from there. Okay, give it a second. to run. And with that, guys, I think I will probably end the stream here. I need to get some breakfast and stuff like that. And I might come back. Do you guys want me to come back afterwards, or do you think we're probably good to go from here? Yeah, so this is quite nice. I like how they're kind of scattering about. They're like little ants. Yep. Okay, that's good. So now they have a clear position. And if we run the simulation for long enough, they'll probably all come back and stuff like that. So let me change this again to a 0.01. Let's write that. And now what I'm going to do is I'm going to go ahead and commit this version to GitHub. Again, we wrote quite a bit today. I think we got a lot done. And I'll do the last simulation maybe on my own, because the last simulation we have to do is visualizing a large network, which is literally the same as visualizing a small network. In fact, let's just go ahead and do that right now. This won't take very long. So let's just visualize a large network. And here's what we're going to do. We are going to say viewer number. That doesn't make any sense. Visualize a large network should not be with viewer number. Let's remove the viewer number. Okay, so let's go over here and let's go to VI. What am I doing? Viral video.ch is what I'm looking for. Draw videos, where am I looking for? Animate viewers, draw viewers, choose videos, provide. What am I looking for? Oh, visualize large network. Haha, I got it. So this is going to be the size of the canvas we're working on. Let's write this. Let's write this. Now, one thing I do have to figure out is how to do individual pixel values for Cairo, but I think we've done this before, so this shouldn't be a big deal. So this is going to be the size of our network. So let's go ahead, or size of our scene. So I'm going to grab this, paste it down here. Okay, so we have to define frame anim as before. Create background should be good. STD vector viewers. Okay, so now let's go ahead and create the number of viewers that we want. So what do we want here? Viewers, init viewers. Okay, so where did we read in? Read in 100? Visualize int viewer number. Oh, what did I do? I think I did viewer number up here. Init viewers, num videos, 100. What? You should definitely read in viewer number here. 1 second, num. Let's pop down here and do viewer number here. This visualization shouldn't take so long, like maybe 20 minutes, so it's fine to do this. So we'll do num viewers here. Oh, sorry, viewer num. Let's pop up here, make sure I did that right. Viewer num correct. Okay, so now we're going to pop down here, and we are going to say viewer number, create background here, and we're going to say up here. So we're going to say resolution X is going to be equal to 400. And down here, we're going to say resolution Y is equal to 300. And 1 second, pop down here, we're going to do resolution X and resolution Y. And now we're going to say that num viewers, here we are, viewer num is going to be equal to that. That seems fine to me. Init viewers, good. So now what we're going to do is with the init viewers command, we're then going to say the following. So we're going to say for viewer number, create background, viewers, num videos. 1 second. What do we do here? We create the vector of viewers, but where do we use viewers? Viewers here, init viewers. Oh, I see. That's down there. Okay, so now what I want to do is this. I want to say viewer number, int viewer number is going to be equal to resolution X times resolution Y. Okay, so what we're going to do is we're actually going to make all the people black for this one, and they're going to turn red as they start watching the video that we're looking at. So we have the update position. None of this is necessary down here. We choose video, watch video. These are all necessary. So we have the viewers. We have the viewers again. Draw viewers. This is not what we're doing this time. So instead we're going to do, I guess we could call it pixel map or something like this, but that's okay. So draw viewers. What are we going to do? We're going to go through all of the viewers, and we are going to, let me see. I got to think about this one. We're going to have a draw viewers command for a whole bunch of viewers. So let's call this draw, I guess, pixel viewers. Okay, and that's what we're going to want. So let's go down to the draw viewers command. Okay, there it is there. Here it is there. And let's go down here and let's do function. Function to draw viewers as pixels in an image. Okay, so we're going to do void draw, 1 second, draw pixel viewers, and we're going to say frame anim, and of course std vector viewer viewers. Okay, and now we just start this function up. So now we go over here and let's go ahead and add this one in there. So we have a draw viewers command. 1 second. The viewers here. And let's go ahead and add in the new function we just created. So it's going to be here. Pop it up over there. Add a semicolon there. Right and quit. Let's make that. See if it works. Don't break on me. Okay, so now we're going to say color black is going to be equal to. And then we're going to do, what do I want to do here? Color black is going to be equal to 0, 0, 0, 1. And then we're going to say color red is going to be equal to 1, 0, 0, 1. Okay, pop that there. Add that guy there. Okay, so now what we're going to do is this. We're going to say for int I equals 0, I less than viewers dot size. And then we're going to do I plus plus. Pop this down over here. And we're going to say, oops, sorry about that. Basically grab this guy. No reason not to. Change this to black. Go up here. And we're going to say color viewer color. Here. Open, paste, and this is going to be black. Okay, good. Okay, so now we have this. So what we have to do now is we have to basically draw every individual pixel. Okay, so we have the pixel map, and we're basically going to say, since we have I, and we're going through all these guys, we will say, oh, we have to find all the X and Y positions, right? So let's go up and let's find X position and Y position. So we'll say int. That's not what I mean to do. Int X position and Y position. Okay, so we'll go down here and we'll say X position. X position is going to be equal to, and it should be, it has some relation to I. And then we want J position, or Y position, to be equal to J. And let's do this like we did before. So we'll say K here, and we'll go up here and we'll say int J equals 0 and K equals 0. Okay, and I forgot a comma here. Okay. Oh gosh, that meant to be a semicolon. And semicolon there. Okay, so now we have K and J. They're both equal to 0. And then we're going to do K++ and J++. Obviously, K++ and J++. And what we're going to do is we're going to say if, oops, sorry about that. If K equals, oh, no, I'm doing this incorrectly. J++ goes in there. If K equals animation.resolution X, we pop down here, and we then say, what do I want to do for animation resolution X? I want to do, I think it's going to be animation resolution X minus 1, probably. But then I'm going to do K equals 0. Oh, I'm sorry. Isn't it K equals minus 1 or something like this? And then J equals 0. I think that's what we did last time. We did a K++ up here. So we'll do K++. There. Okay. So now we do a DD there. And I think this should do it. I don't know what I'm doing with spacing here. Something like that should be okay. Okay, so let's go here, let's there, and let's make. Okay, so now resolution X is not declared in this scope. That is because resolution X. Oh, let's go to 444. Int. Okay, so now it should make. Okay, Y X position is set but not used. Y position is set but not used. That's fair enough. Let's go down here. G. Draw pixel. Where are we? Here we are. Draw pixel viewers. Next. Draw pixel viewers. X position equals K. I guess we'll just go ahead and set this guy to 0. And we'll go down here. And we'll do int. Y position. This one also equals 0. And I'll go over here and do this. Let's go here, make. It's fine. I mean, whatever. They can complain all they want. Okay, so what do I want to do next? We have the X position, Y position, everything should be set. So now what do we need to do? We have all these guys, draw pixel viewers. Oh, so now all we have to do is actually draw the pixels. So what I'm going to do is I'm going to go into VI ... into geometrical optics, which is where we've done this before. And I think we have an optics visualization.cpp. And let's see, what do we have? We should have a create frame, grow circle, animate line, draw layers, animate circle. No, none of these are what I want. Where would they be? Animate line. Quit. Let's see, what else do we have there? We have optics visualization. Maybe it was an optics visualization. Optics visualization.h though. Let's see, what do we have here? Animate circle, templates. So we have draw lens, index plot. That's what I'm looking for. Let's go down to index plot. What do we have here? Index plot. Vertex.x. Let's see, we have location.x is I, r prime distance, if r prime, Cairo set source RGBA. Okay, here's what I want. So I want to create a Cairo rectangle at these points. So we will do the following. We're going to say, 1 second, I gotta think here. It's gonna take some time. Okay, so we're going to say Cairo rectangle here. Bam. So we get the Cairo rectangle. Then we do Cairo set source RGBA and Cairo fill. Open. There. Okay, so now we have to set this up for what we need. Let's go ahead and remove a couple spaces here. Okay, so we have frame context, frame number, that should be okay. Do we have to move these guys? I don't think so. I think this should be okay. So we're going to say animation frame context, frame number. Yes, so we have a whole bunch of frames that we're working with here, but I think we can just do current frame for this one. Current frame. There. And we'll do current frame. There we go. And then down here we say current frame. Oh, that wasn't what I meant to do. My bad. So we're going to do current frame over here. And again, guys, if you have anything you want to say, let me know. So animation dot here. And we're going to go down here. Location.x, location.y. This is just going to be X position and Y position. So it can be X position. Sorry, I forgot an S. And Y position. Now we go down here and we do lens color.r. This is not correct. It should be, 1 second. What do we do? Wait, what do we make, if I may ask, and how is it related to a viral video? Yeah, so basically what we're doing is we have a network of people, okay? This network of people is modeled with an epidemic algorithm. We give 10 people initially, your subscribers, basically videos, and we watch that video propagate through this network. Okay, and so what we're doing now is we're visualizing an incredibly large network of people and seeing how the video propagates in this network. So that's what we're currently doing right now. So what we're going to do is we're going to say viewer color. 1 second. Viewer color dot R, and basically change all of these guys to be viewer instead of lens. And viewer here. Okay, and what's this last one? I think it's just gonna be viewer color. There, okay, so let's see what happens if we go here, go over here, right and quit, and let's make that. Error in viewer VLR is not a thing. It is, of course not. So let's go ahead and RC, and let's make that. Okay, so this one seems to be making okay. Let's go up here to the top, and instead of visualize moving network, let's visualize large network. Of course, we don't need an integer for this one. Let's make that. Give it a second and let's run the visualization. Let's do, where's the last one? Viral video. Okay, give it a second to do its thing. And then I think we'll call it for the day because we've done the 3 big visualizations. We have 2 small visualizations to do, but that shouldn't take so long, I don't think. Yeah, and in fact, we might come back tomorrow if I see that it does take a while. I just figure I should go get some breakfast and stuff like that now. Give this guy a second to run. It'll take a little bit longer than the other visualizations because we have a much larger number of people. Oh, in fact, I just realized we have an incredibly large number of people. Yeah. Maybe I should have tested this in another way. Or maybe I should have added some paralyzation or something. Yeah, maybe that's what I should have done. Yeah, I definitely should have done some paralyzation here. Because there's no reason not to, right? Okay, so what I will do is... quit this, and make a much smaller image. It's just a 10 by 10 image for this one. And then we will we'll speed it up in a bit. Subdate position, where are we? Visualize large network. Okay, visualize large network there, and let's just make this a 10 by 10 image for now. Now let's go over here and make that. Give it a second to do its thing, and now let's do viral video. Give it a second, this shouldn't take any longer than the last one. Okay, so now we're gonna do, where's the last mirage? There it is. Okay, so these are images, and okay, so that wasn't quite what I was expecting. It looks to me like all we're doing is just, yeah, for some reason they're white. I don't know why they're white. They shouldn't be white. Yep, that's not right. Okay, so let's go down to visualize large network, and let's see what happens. Oh, we're already in it. So draw pixel viewers, that's what I need to go to. Find affinities, this should all be okay. Let's do draw pixel viewers. Pop down here, draw pixel viewers. Red, black, 0001, should be okay. So they're all black to begin with, then they're all red after that, but for some reason it's drawing them all white. Not sure about that one. Let me see. It's also not popping up the pixels correctly.